Hi everyone, welcome to this live stream for HashiTalks India 2025. Good morning, good afternoon, good evening, wherever you are watching it from. I am Adit Muti. I am an HashiCorp ambassador and an HashiCorp user group co-organizer, and I am joined by Neil. Neil, would you mind introducing yourself?
Yeah. Hi everyone. Welcome to HashiTalks India 2025. And I'm Neil Shah. I'm one of the HashiCorp ambassador and I also running the HashiCorp user group Gandhinagar. Welcome you all today.
Yeah, welcome you all to the live stream for HashiTalks India 2025. Before we start, if you have, you can just mention where you are joining us from. Maybe just say hi, I'm joining from here, etc., etc. It would be helpful for us. If you have any questions or comments, do let us know. Also, just drop them in the chat, and we'll be happy to address them. Also, as you know, we do have a code of conduct for this virtual space. In general, it is be welcoming, inclusive, friendly, and patient. Be considerate, be respectful, and be professional. You can review our code of conduct at hashicorp.com/community guidelines. I think with that said, let's get started. Maybe Neil, would you mind, introducing the first speakers for this event?
Yeah, sure. So we had a quick overview of HashiTalks program for the today. We had a lot of excited speakers coming up today, have performing a lot of different projects and a lot of products of HashiCorp. So coming to that, we had our first speaker, that is a joint session by Dr. Rahul Sharad Gaikwad and Pranit Raje. They will be sharing insights on Terraform actions, revolutionizing the infrastructure lifecycle with smarter automation. So let's jump on to our first session today.
Hello everyone, welcome to HashiTalks India. I am very excited to have you all join us for a day of learning and sharing. Being a tea lover, I often like to make a perfect cup of tea. We call it as a chai in India. I always think it's ready to drink, but then someone says, "Hey, can you please add a little more sugar or ginger?" It's the same with the Terraform apply, right? You run the Terraform apply, everything looks green, and then you realize there is more to do, right? For example, stop an EC2 instance, run a playbook, or maybe clear a cache. That's where Terraform action comes in. It goes beyond just the provisioning. It handles those real world post deployment tasks automatically. So today I will not be doing this presentation alone. With me, my colleague Pranit Raje will join us in the second half of the presentation. And I have added the QR codes of our LinkedIn. If you have any questions about this presentation, please feel free to reach out to us on the LinkedIn. So before we start, let me deploy my own resource first, right? Where I'm talking about the introduction. I am Dr. Rahul Gaikwad, working as a staff resident solution architect here at HashiCorp, an IBM company. I spent over 15 years helping enterprise modernizing their cloud infrastructure and accelerate their cloud adoption journey. I'm based out of Pune, and my expertise lies in DevOps, cloud, and generative AI. I have done my PhD research in artificial intelligence in IT operations. So here is what we will cover today. We will start with the some of the common challenges that customers face in today's cloud operations. Then I will introduce you to the Terraform Actions, a new way to bring your smart automations into your infrastructure workflows. Next, we will look at how Terraform actions actually solve those challenges. And then, as I mentioned, Pranit will join us in the second half of the presentation. And then he will walk through real world use cases, and then he jump on the live demo to see it in the action. Finally, we will wrap up with a few key takeaways and lesson learned. Okay, before we deep dive in today's topic, let me set up some context. We are stepping into the next era of infrastructure automation. For many years, our automation has focused on the efficiency. whether it's replacing manual efforts with some scripts or templates or infrastructure as a code, right? But today, that conversation has evolved over the time. We are moving towards a model where infrastructure is not just about executing the instruction, but it understands your intent as well. The next era of automation is not just about the technology, but all about the transformation. So let's deep dive. Let's try to understand your infrastructure lifecycle management. It starts with building secure, reusable components like AMI or Lambda templates. Then you deploy that infrastructure maybe in the cloud or on-prem. And then you manage all this post-deployment operations. So on day zero, you basically do the build and plan where you will codify your infrastructure using Terraform ISA. On day one, you basically deploy those ISC templates across the environments. And your day to day is mainly focusing on managing and operating the infrastructure over the time, like restarting the EC2 instances or maybe patching, monitoring, or other automation tasks, right? Let me give an example. For example, if your application consists of bunch of EC2 instances, what you will do on the day zero? You will actually create a base AMI where you will install all the required libraries. Then on day one, you will actually deploy that infrastructure as a code in your on-prem or maybe on the cloud across the environment, right? So basically provisioning your infrastructure on the day one. Day to day is basically automating or executing the shell scripts as a post deployment operations. For example, restarting application services or invoking specific Lambda function or some patching or some monitoring operations, right? So let me give another example. If you have applications like an event-driven application where you have a bunch of Lambda functions. So on day one, sorry, on day zero, you will actually build a Lambda in Terraform, and then you will deploy that Lambda. And on the day two, you invoke those Lambdas. So this is how your infrastructure lifecycle management look like. Okay, let's talk about some challenges in today's cloud operations. Many customers are facing challenges in managing infrastructure due to growing complexity, maybe multi-cloud, multi-environment, multi-account, or hybrid cloud model. Let's deep dive into those challenges. Customers were feeling like there is a lack of native way to define and trigger these day two operations, like patching, restarting services, or triggering a job through existing ISC. So each team built their own scripts or workflow to manage all these day two operations, which leads a lot of time of inconsistency. As all these day two tasks often ran outside Terraform via shell scripts or provisioners like remote execution or local execution or sometimes manual event triggers. The fragmentation tooling breaks their automated workflows, right? If day two operations performed outside the Terraform lifecycle, which gives limited observability and which causes the drift issues. As there is no integrated way to track all these changes, which leads to governance and compliance issues at organization level. With that, let me introduce Terraform Actions, which is an evolution in infrastructure automation. They enable you for managing real-time event-driven operations like patching, restarting, scaling, and remediation directly from your Terraform codebase natively. As you know that Terraform is good at managing your infrastructure resources through CRUD operation, that is create, read, update, and delete operations. Terraform actions actually goes beyond that CRUD operations and enable you to perform day two operational activities at scale. So what are those common use cases which supported by Terraform actions? You can actually invoke a Lambda functions without redeploying that Lambda function. You can run a shell script. You can configure your virtual machine via Ansible scripts. You can restart your application services. You can take a database snapshot before performing any database operations. You can invalidate your cache. You can also trigger a webhook and send some messages to your Slack channel. All actions triggers from your Terraform workflows. Now let's talk about how Terraform actions can solve these day two operational challenges. You can add an action block to your Terraform configurations and specify the type and a label as inline arguments. The type of action depends on your provider. You can use the conflict block to specify your provider related arguments. You can specify arguments such as count or provider or any other blocks like for each in your config block section. You can integrate this action with any resources by defining it into a lifecycle block. You can add a action trigger block with required conditions and events that triggers that actions. You can specify what triggers the action, when it should run, and which action Terraform will execute in that response. You can invoke these actions directly from CLI by passing invoke parameters with required arguments. Now let me show you how Terraform action works in code. So I have a sample code here which has a standard configuration. I have defined the provider, IAM role with required policy and zip file. And this is my typical Lambda function, which has hello world function. You can see here, it's a standard Lambda function. And then I have a special block here, action. You can see, let me pause here. You can see I have defined the action block with AWS Lambda invoke and sample as a label. And then I am actually calling that function name and providing some sample payload. So let's see, let me deploy this Terraform configuration. Let me show you first the Terraform version. Currently, as it is available in the beta version, I have upgraded my Terraform CLI to the version of 1.14. Then I will just do a standard Terraform init and Terraform apply, which will actually provision all these resources. And you can see in the apply, it will actually deploy three resources, IAM role and permission and the Lambda function. So once it is done, your Terraform actually deployed your AWS Lambda function. Now, in the next post operations, I just wanted to trigger the Lambda function without redeploying the entire Lambda code. So this is the CLI command that I will run Terraform apply with invoke as a argument with the required parameters. And you can see it has invoked just the Lambda functions without making any changes to the actual resource, right? You can see here action is one invoked. Now what I will do is I will just add one more argument here, count 2, so that when I run the Terraform actions again, it will invoke that Lambda function twice. This is very simple invocation method. Now let's do one more thing. Let's add some complexity. What I did is I added one more resource, that is AWS instance, and then we'll invoke our Lambda function based on the some actions which is defined in the lifecycle of AWS instance as action triggered. You can see whenever there is an event like after create or after update on EC2 instance, it will automatically invoke that Lambda function, right? So this is how you can integrate actions with action trigger. And let me just quickly verify I have Terraform version. which is 1.14, and then I will just quickly deploy that infrastructure with Terraform apply, and you can see it is actually deploying 4 resources, and then it will invoke one Lambda function because we have put a condition create and the update one. So let's see what resources it's provisioning. It's provisioning IAM role Lambda function EC2 instance, and then based on that action, it will invoke the Lambda function. It's creating all these resources, and as soon as all the resources provision, it will automatically trigger the Lambda function. Yeah, you can see here it's invoked the Lambda function, right? So now we have put the 2 conditions, right? After create and after delete. Sorry, after update. So we have seen after create one. Let me make some modification in the EC2 instance by updating the tag, and then I will just redeploy that infrastructure again, and let's see what action it performs. So it will just rerun the flow, and it will not make any changes to the existing resources, but it will just invoke the Lambda function based on the update trigger. You can see it has successfully invoked the Lambda function. That's how you can integrate the action with some resource in the lifecycle block. Now, after watching how Terraform action works in code, now you may have a lot of questions about Terraform actions, like which provider and resources currently it's supported, where and how can I check the supported provider and action list, right? So let me give an overview of current status of Terraform actions. Terraform action was announced last month in HashiCorp 2025, where I attended myself in person as a HashiCorp ambassador. It's available in public beta from 1.14 onwards. Currently, it's supported AWS and Azure as a cloud provider. There are few ways actually you can identify available actions from each provider. First, you can use the automated script developed by one of my friend under the extract provider supported actions public repo. And I have given the simple screenshot as well where I tried that script myself, and it has given a nice summary of all the cloud providers and the resources. There is another way you can use the Terraform MCP server to ask the natural language questions and get the answers quickly. I will quickly show you how to use it. So as you can see, I have used the Terraform MCP server, and I'm just asking the basic questions. Hey, which Terraform actions currently supported on Terraform providers? And you can see it has given me quickly the detailed summary, including all the AWS providers, Azure providers, Google providers, and all the key points. Then let me ask the another follow-up questions. I'm asking, give me the relevant use cases for all above Terraform actions. And it has nicely given all the real use cases for all the actions, right? And you can see you can interact in the natural language questions with this Terraform MCP server. Now I will ask the specific questions with the cloud provider. In this case, I'm asking specific to AWS, which actions are supported. It has given me all the list against the resources. And then I asked the same questions for Azure. It has given me one Terraform action is currently supported. The same question I tried with GCP, and you can see currently GCP, there is no Terraform action supported. Then I asked the questions around Ansible automation platform, and you can see it has given me the supported resources, all the details around the key features, use cases, right? With the help of Terraform MCP server, you can get all the required information around the Terraform actions. Now let me quickly talk about some of the important key benefits you can expect for your teams across the organization. There are a couple of key takeaways from our talk that I want you to remember. The first is that Terraform Actions enables you to standardize day 2 infra operations. You can actually codify your day 2 activities in Terraform. You can streamline your automated workflows by eliminating the need to use the external tools for post-deployment tasks, like invoking the Lambda functions or clearing the cache. You can manage the day 2 operations in single control plane. Day 2 operations natively supported by Terraform through actions. This standardization allows you and your team to declare day 2 operations as a single source of truth and manage the resources. It will increase the observability and it will help you to reduce your compliance and governance issues. With that, let me hand over my friend Praneet to talk about real use cases and demo. Thank you so much again for joining us at the HashiTalks India. Wishing you all happy terraforming throughout the HashiTalks India. Thank you.
Hello everyone. My name is Pranit Raje. I work as a solutions architecture specialist at HashiCorp, an IBM company. I have a total of 7 years of experience in IT industry, specifically in cloud, DevOps, etc. So now that we have seen how Terraform actions could be beneficial in standardizing day 2 infrastructure operations, let's understand it in a bit more detail with the help of a real world example. Imagine you're operating a retail website which hosts its media content on top of Amazon Simple Storage Service, which is also known as AWS S3. Additionally, you're also using AWS CloudFront, which is a global content delivery network, to cache your website content like web pages, videos, images at edge locations, which are often closer to your end users. Now, obviously, there would be times when you have to make a new deployment for your web pages where you would like to let your users know that a specific item from the catalog has been sold out and it's going to be unavailable until next time. But since you're using a CDN which is backed by a worldwide network of edge locations, these changes could take some time to get updated all over the world. Your users could still access the outdated web pages and may face some errors while ordering some of the items from your website. You don't want to frustrate your end users, right? Detrimental for your business. So, what were the solutions being implemented until now by infrastructure teams to tackle these cache miss problems? One of the solution was that few people used to manually invalidate the CloudFront cache, either from the AWS console or via some AWS CLS scripts after every new deployments. Then some people used to have a dedicated CI/CD pipeline, just as you can see in the architecture diagram on the right hand side. As soon as any changes are made to the website repository, those pull requests used to trigger the AWS code build builds, wherein you run the AWS CLI commands to sync the S3 bucket content and also invalidate the CloudFront cache. Or next, I have also seen few customers turning on S3 object level logging, then configuring CloudTrail events for those S3 bucket, and then setting up event bridge rules for invalidating cache whenever any put object event occurs. All these workarounds do exist, but let's be honest, they do come with lots of challenges like risk of human errors, then slowing down the release cycles due to multiple steps in between, These day 2 tasks can leave us with complex and disjointed workflows. So, how do we address these challenges with Terraform? Here comes the Terraform actions to the rescue. For this specific scenario, we have a native action from Terraform named as AWS CloudFront Create Invalidation. You can see the snippet of the code on the right hand side, whereas if the index.html page is updated, we want to automatically invalidate the CloudFront cache so that the new HTML content is displayed to the users directly and instantly. For this, we are using action trigger block nested inside the lifecycle block. Then the specific event that we are listening on for the index.html is after update. Once that event occurs, we call the update action defined just below that for every path of the website. So you can see we don't need any external scripts or CI/CD pipelines, but we just needed a couple of lines of Terraform code to perform the same action. How easy that is, right? So folks, you must have realized the significance of Terraform actions. It provides you the benefit of fully automated cache management for your website within the same Terraform workflow. By codifying such day 2 operations, organizations can reduce the operational cost and accelerate the deployment pipelines by automating manual and error-prone processes. Overall, what could be better than the improved end-user experience, right? You make your users happy, it will make your business happy. Win-win situation. Now that we just saw a snippet of the solution, let's also have a look at the whole end-to-end workflow with a full example in a live demo. So this is my static website page hosted on AWS CloudFront. This is the CloudFront distribution which is having S3 bucket as an origin. And this is the bucket where I have hosted the index.html as well as error.html pages. Now let's have a look at the Terraform code which has provisioned these resources as well as managing the same, starting with the S3 bucket for my website hosting. And then the CloudFront distribution. Next is my S3 object which is defined for the index.html page. And within the same resource, I have defined my lifecycle as well. So I have defined after update as an event. So as soon as the object is updated, it will invoke the CloudFront invalidation action. And the definition of the action can be seen below. Now let's make a minor update to my index.html page. And let's commit the same to the backend GitHub repository. So as soon as the commit is made, it will trigger my Terraform run operation from the HCP Terraform console. So this is my HCP Terraform console where I can see the latest Terraform run operation that has triggered with the latest GitHub commit. Now it has started the Terraform plan operation right now. Let's speed up this demo a little bit. Now I'm confirming the Terraform plan operation and proceeding towards the apply operation. It will take a couple of minutes to get updated in the console. So if you see the CloudFront distribution console, you can see the invalidation has been started. And we can see the detailed logs of that invoked action in the same HCP Terraform console. If I check the invalidation process, it has been completed. And if I just refresh my page, I can see the changes reflected instantly. Awesome. So we just saw in the demo how we can write new Terraform actions for one of the use cases. Now let's see what are a couple of factors to keep in mind while integrating Terraform actions into your existing workflows. Starting with the discovery, we need to analyze our end-to-end infrastructure workflow and find out those steps where we are still doing some hacky fixes like manual operations or some messy scripts for repetitive tasks. Then we need to set the order of priority for those tasks which are causing delays to our deployments. Once we have identified those gaps in automation, we can think about incorporating actions in our infrastructure as code templates. Now, obviously, we need to check what are the native actions available from the official provider documentations or the way which Rahul previously showcased from the GitHub repository. As of now, we have 4 different event triggers available that are before and after create and before and after update. So whenever your resources are going through these lifecycle events, your actions will get triggered automatically. On top of that, we also have a flexibility to conditionally trigger an action. So you can control if an action is invoked or not using a condition expression inside of the action trigger block. If the expression evaluates to true, the action will be invoked. Now comes the most important part. What are some of the best practices while implementing actions? Starting with the first, what if your actions fail due to any unforeseen circumstances? Because things fail all the time, right? So your actions should be always retryable. The end logic in your action definitions, be it your Lambda invoke scripts, be it your step functions, or even your code build scripts. In case of a failure, it should be able to run again without any issues. Next, second, as we spoke in the last slide, use conditions to limit when actions run. For example, only run this trigger if the environment is production or when a flag is true. Next, let's say you're running an Ansible playbook or some Lambda functions via actions, and the playbook is taking a couple of hours to run. So obviously you don't want to wait for such a long time within your Terraform runs, right? In that case, it might make more sense to trigger some asynchronous workflow rather than getting stuck at Terraform runs. So you should avoid synchronous tasks in your action definition. And last but not the least, keep your Terraform template dry. Don't repeat yourself. We are back to basics. So you should create reusable modules of common actions in your workflow. So what did you learn so far from this presentation? There are a couple of key takeaways from our talk I want you to remember. First, actions eliminate the need to switch between tools for post-deployment tasks like Lambda invocations, CloudFront invalidations, etc. By codifying these day-to operations alongside your infrastructure definitions, teams gain a single control plane, reducing manual errors. And second, actions can be bound to resource lifecycle events such as before create, after update, etc. Or they can also be invoked ad hoc via CLI commands. This standardization allows module authors to declare day 2 operation as code, providing clear associations between actions and managed resources. With that, I would like to thank you for your time today. Happy terraforming! Thank you for joining today's HashiTalks on Terraform Actions. Hope you find the session informative and engaging. Your feedback is invaluable to us. Please scan the QR code on the screen to share your thoughts. Thank you.
It was amazing session by Dr. Rahul and Pranit. Terraform Actions, I think, is like a new way to automate your day two operations, right? Uh, any thoughts on the session, Neil?
Yeah, it was amazing. Like the action, if we can configure all the workflows from a single pane, and also the Terraform MCP. A lot of people were crazy about that.
Yeah, understood. Correct. So just want to address two comments. One is the Terraform Actions is available via CLI, as well as you can use it via the Terraform Cloud as well. And second thing is all of the sessions that you see here will be later on uploaded to YouTube. So you could maybe check them out later on, or if you are joining in late, you can check out the sessions later as well once they are uploaded to YouTube. Right. I think, yeah, with that said, Neil, maybe introduce the next speaker.
Yeah. So how can any HashiTalks would be there without a vault? Because there are a lot of
Yeah.
things around secrets. So the next talk is by Anurag Dutt, and he will cover secrets without fear. So he will cover a lot of things around managing sensitive data with Vault. So let's jump on to our next session.
Hey everyone, I'm really excited to be here at HashiTalks India. I'm Anurag Dutt. I work in cloud and DevOps space, helping teams design secure, scalable infrastructure. Over the last few years, I've worked across multi-cloud environments, building automation pipelines, and honestly learning a lot about what not to do with secrets. And that's what brings us here today. I want to share a story about how we learned to manage secrets without fear. Things like API keys, credentials, tokens, the kind of secret that make everything work but often end up being scattered, hard coded, or shared in ways we regret later. So, when we started facing those exact challenges, we turned to HashiCorp Vault, and it completely changed the way we handle sensitive data across our environments. So, today I'll walk you through that journey, how we adopted Vault, the bumps along the way, and the lessons we learned during the rollout. So, here is what I'll be walking you through today. We'll start with the challenges, why managing secrets has always been a bit of a headache for most teams. Then I'll introduce Vault and share how we adopted it across different environments, from AWS to Azure to Kubernetes. And I'll also talk about the bumps we hit along the way, some lessons we learned, and finally wrap up with a few practical steps that you can take to start improving secret management in your own setup. So, sounds good. Let's dive in. So, if you ever hard coded an API key just for testing, you know where this is going. So, secrets have this funny way of spreading anywhere, into config files, pipeline variables, even Slack message at 2 a.m. when someone is debugging a build failure. So, over time, these temporary fixes become permanent risk. So we skip rotation because they are manual. We copy credentials across project to save time, and before we know it, no one knows where half the secrets actually live. And visibility becomes a guessing game, and compliance audit, they are, let's just say, not fun. So this was exactly situation we were in before we bought in Vault. So the scary part is the impact. A single leaked key can trigger a full-blown security incident. Sometimes it's public exposure, sometimes It's just a misused credential. But either way, it's a long week for the ops team. Then there is a manual rotation. Every time you rotate a secret manually, something breaks, a pipeline falls, a service goes down, or someone forgets to update a dependency. And the worst part, without centralized visibility, you can't even prove you are compliant. So it's chaos discussed as control. And that's exactly what pushed us to look for a better way. Vault bring calms to this chaos. So think of it as a single central brain of all your secrets. It doesn't just store secrets securely, it can actually create them dynamically and retire them automatically. You can define exactly who gets what, for how long, and under what conditions. And the best part, every single access, every token, every rotation, it's all tagged in the audit logs. With Vault, secrets stop being something you fear and start being something you manage confidently. Now that we have covered what Vault is, let's take a look at how it actually works in action. So, on the left, we have our clients. This could be application, CI/CD pipeline, or DevOps tool, all needing access to secret like credentials or API keys. So instead of storing these secrets directly, these clients authenticate with Vault using method like OIDC, Kubernetes auth, or app role. So once authenticated, Vault checks the authorization policies to determine what each client is allowed to access. Then comes the core part, the secret engines. These engines either generate secret dynamically, like AWS credential, Azure tokens, or database password, or return data from a key value store. The secrets are then sent securely back to the client, and most importantly, they expire automatically. This reduces the exposure window and enforces good security hygiene by default. And behind the scenes, Vault keeps its state and metadata in a durable backend like Raft, ensuring high availability and resilience. So, in short, clients authenticate, Vault validates, secrets are generated or retrieved dynamically, and nothing lives longer than it should. So, that's the beauty of Vault. It turns secret management from static storage into an automated system of trust. So, our story with Vault started small and very practical. So, in phase 1, before Vault, we had secrets scattered across AWS and Azure and some buried deep inside CI/CD pipeline. It worked, but it wasn't scalable or secure enough. So, then in phase 2, pilot, we started lean, using the Raft backend for simplicity, integrated GitHub Actions, and onboarded two critical apps, just enough to validate authentication policies and the automation workflow. Then in phase 3, at the time of scaling, once the pilot proved stable, we expanded, added Azure Secret Engine, connected Kubernetes cluster through the external secret operator, and centralized the our access model. So each phase taught us something new, from chaos to structure, from static secrets to automated trust. This gradual approach made Vault adoption smooth, confident, and measurable. So, yeah. So integration wasn't without hurdles. Developers were hesitant. One more tool meant more friction. So we kept onboarding simple using templates and easy default. Then we ran into token sprawl, too many long-lived tokens, adding overhead and risk. So we solved that with the short-lived TTLs and automatic revocation. And policies also become a tangle fast. We switched to a minimal ACL model, start small, expand only as needed, and finally visibility. We didn't know who was accessing what, so we enabled audit logs early, which gave us clarity and accountability. These steps helped us to move from resistance to adoption. So building trust, not just enforcing the rules. So next is, yeah, scaling across multi-cloud or Kubernetes. After proving Vault's value, scaling was the natural next step. We positioned Vault as our single source of truth. It now serves secrets across AWS, Azure, and our Kubernetes clusters, all from one central point, right? So the real magic came with namespaces. Each environment, production, staging, and development got its own isolated namespace. That meant clean policies, independent secrets, and zero risk of accidental cross access. This design not only streamlined the operation but gave every team clarity. They knew exactly where their secrets lived and who could access them. So yeah, this was the scaling scenario. Then comes the lessons and wins in this process. The transformation has been dramatic. What once required manual effort, like rotating credentials, tracking scattered secret, is now completely automated and centrally managed. Hard coded secrets gone, credential renewals automatic. Every secret is now auditable, traceable, and compliant by default. What used to take days now take hours. Vault doesn't just secure our environment, it made us faster, more confident, and completely in control across every cloud and cluster. This shows how small shifts in approach can create a big wins, safer, smarter, and simpler operations. Uh, then comes the actionable steps. If you are planning to roll out Vault in your own environment. So here is what worked really well for us. So try starting small, pick one app, one team, and prove the value early first. And don't try to boil the ocean in one day. So, and next, automate credential renewal as soon as possible. This single change eliminates so many manual errors and build trust in the system. And keep your ACLs and policies simple. Over engineering access controls early just slow you down. Evolve them gradually as your needs grow. Okay. And use namespace smartly to separate environments like prod, stage, and dev. It keeps governance clean and friction low. And finally, train your developers, help them understand not just how Vault works but why it matters. Because once they see how much time and risk it saves, adoption becomes organic automatically. Uh, so that's our journey from scattered secret to secure centralized simplicity. Secrets don't have to be intimidating. With the right tools, the right approach, and just a little discipline, you can manage them fearlessly. Thank you so much for tuning in to my Hashi Talk India session. I'd love to hear how your team handles secret and what lessons you've learned along the way. Let's connect and keep managing secrets without fear. Thanks. Have a great day.
Another amazing talk by Anurag on Vault. I think it actually makes sense to use Vault for your multi-cloud environments, right? When he mentioned about different cloud providers and using Vault as a secret tool or maybe for storing your secrets, I think it makes a lot of sense, right? Neil, any thoughts on that?
Yeah, so his real world experience was amazing, and the tips were perfect because a lot of people started using Vault, and nowadays a lot of companies are using Vault.
Yeah, yeah, totally makes sense.
Yeah,
I think,
and
yeah, Neil.
uh, talking about some of the HashiCorp user groups across the globe. So the HashiCorp community spans in more than 65 plus countries, over 60,000 plus users you in the HashiCorp user groups. And talking about India, so in India there are 19 HashiCorp user group chapters. And if anyone wants to join the chapter, The link is like hashi.co/hugs. They call it as hugs, HashiCorp user groups. To find the chapter near your city, and do join that, because it is a virtual event, but many lot of offline events are also happening across India, across the globe. So do join them and do utilize them. Over to you, Aditya.
Yeah.
Let's continue on this.
Yeah. So HashiCorp user groups, I think one of the interesting HashiCorp user group meetup is happening in Bangalore. They are hosting their first HashiCorp user group. So if you are in Bangalore on this weekend, do try and join HashiCorp user group meetup. I will be able to chat more because I'll also be joining you. And apart from that, I think apart from the HashiCorp user group, the HashiCorp community also has the HashiCorp Ambassadors program. Both Neil and I are part of the HashiCorp Ambassador program. And if you would want to be part of the HashiCorp Ambassador program, the link or the invite to it opens once every year. So do try and advocate for HashiCorp products. Do try and or share your knowledge about HashiCorp tools. Maybe it is around Terraform, Vault, or any other tools that you want to. And share more about it, and then take part and join the HashiCorp Ambassador program as well, right? I think, yeah, with that said, we would want to jump onto the next speaker. So our next speaker for this event is Glenn Chia. He is a solution architect at HashiCorp itself, and his talk, I think, is very relevant in this day and age. It is around Terraform modules, and like managing this Terraform module lifecycle, like deprecation, then exploration, then change request and notification, right? So I think it makes a lot of sense, right? Whenever the Terraform modules are maybe out of sync, right? How do you communicate that out of sync, right? How do you ensure that no one now uses the outdated or deprecated modules, right? I think hopefully it will make a lot of sense to people. So yeah, over to you, Glenn.
Hello everyone, thank you for joining us today for HashiTalks. Today, we'll be talking about managing Terraform module lifecycle. Some concepts that we will go through include module deprecation, using the Explorer for workspace visibility, leveraging the change requests feature, and getting notified on change requests creation. I'm Glenn, a solutions architect at HashiCorp, and I often get questions from the field about how to detect which workspaces are using old module versions, what module versions are being used, and how we notify teams at scale about requirements to upgrade these modules. These are some questions that I'll be addressing during this talk. This is what we will cover today. I'll share some basic module terminology to start with, before diving into the module lifecycle, from writing to publishing to deprecating and upgrading. Then, we'll go into the visual parts where I have a demo showing how tag-based modules work and how workspaces consume these modules. I'll then show how we can deprecate and revoke modules, which have slightly different behaviors. Then I'll show how Terraform teams are set up to receive notifications on workspace change requests. Finally, I'll walk through how we can use the Terraform Explorer to detect information about module usage, create change requests, and receive notifications on those change requests. Let's begin with module terminology by going through a quick module refresher. A module is a container for multiple resources that are used together. A common use case of a module is when you repeatedly provision collections of resources with similar configuration. For example, in this screenshot, we see a network module. This network module is an abstraction of how VPCs and subnets integrate with each other. For this specific module, it contains a VPC with one subnet. For someone else using the module, they might have a different VPC CIDR. Instead of duplicating the resource blocks, they can simply use the module abstraction and pass in their own value in the base_CIDR_block variable. We can also chain modules together as shown here, where the network module's output is referenced in the database module. Notice that each module also has a version constraint associated with it. For module versioning, we recommend following semantic versioning. A guide on semantic versioning is shown here, where it is split into major, minor, and patch versions. Patch versions are typically backward compatible bug fixes. Perhaps you're fixing a typo within the Terraform configuration. Minor versions are usually used when you're adding new functionality that is backward compatible, meaning that module consumers do not need to modify any of their Terraform configurations, and new plans will typically show no deltas. However, they can choose to add new variables to utilize the new features implemented. Finally, major versions are used for incompatible API changes, which typically introduce new behavior. This will likely involve module consumers introducing required new variables or renaming existing variables. An example of semantic versioning can be seen in a VPC module within the Terraform registry. We see a mix of major versions in the 6. series and 5. series. We also see minor versions like 6.2.0 and 6.3.0. Finally, we see patch versions where we have 6.4.0 and 6.4.1. This module has an accompanying GitHub repository where we can see the release notes of each version. Here, the patch version involves a bug fix. The minor version shows a backward compatible fix that does not require module consumers to make any changes, and then the major version shows a breaking change where module consumers should bump their provider versions accordingly to use the 6. versions of the module. Beyond semantic versioning, there are other terms we use in relation to operating modules. These are also features in certain tiers of HCP Terraform and Terraform Enterprise. Refer to the pricing page linked in this slide at the bottom to see which of the features are supported depending on which platform you are running on. The first is deprecation and revocation. For older versions, we might want to deprecate the module version to let consumers of the module know they should be upgrading their modules to the latest version. Deprecating does not stop existing or new users from consuming the deprecated version. It only adds warnings to new runs using the deprecated module version. For other modules, we might want to be stricter in this enforcement. Revoking a module version takes it a step further by preventing new users from consuming that module version. This means that new Terraform workspaces with configurations that reference a revoked module version will face an error if they attempt to run. The second is the Explorer. Some views that the Explorer can show are the top module versions used, the modules that each workspace is consuming, and their versions. We can even do filters to find out which workspaces are not using a particular module version, something that we'll do in the demo later. Finally, we have change requests. From the Explorer view, after filtering out workspaces based on a certain criteria, for example workspaces that are not using the latest module version, we can create change requests on these workspaces to notify teams that manage those workspaces that they need to take action to upgrade their modules. We'll see how each of these features are used in the demo. Now that we have defined what a module is and the value of semantic versioning, let's look at the module lifecycle. Terraform supports two module publishing workflows, branch-based and tag-based workflows. Both workflows are similar with some slight differences. This diagram shows the flow for branch-based workflows that as of this recording is the flow that supports tests in the private module registry. For branch-based workflows, it starts with creating a repository that will contain the module code. Module producers will then write Terraform configurations for the module, write tests, and create examples for how to consume the module. They will then validate and format those configurations, which can also be achieved through pre-commit hooks. When the module is ready, they will make a pull request. When a pull request is made in the branch-based workflow, Terraform tests are executed in the private module registry. The PR is then validated for Terraform best practices before it is approved and merged to main. Merging to main runs Terraform tests again in the private registry. Once all tests are passed, we can then publish a new version based on semantic versioning. So what happens after we publish a new module version? At this stage, we ideally want module consumers to use the new version. We can choose to deprecate or revoke older module versions with a message shown to module consumers that there is a new module version available. In addition, we can also send notifications to the specific teams managing workspaces that are using old module versions. We first want to discover the workspaces that are using an older version of the module. Once these workspaces are identified, we can create a change request for these workspaces. Notifications are configured on change requests created. Notification destinations include email, Slack, Microsoft Teams, and webhooks. Once teams receive the notification, they can then take action to upgrade the modules. With the theory covered, let's start our demo. For the first part of this demo, we'll be looking at how to use the tag-based publishing workflow for modules and how we can create Terraform workspaces that reference those modules by specific versions. This is part of the larger demo. This architecture diagram shows what we'll be covering for the demo. We see that there is a Terraform module created within the Terraform private module registry. This module is integrated with a GitHub repository. This GitHub repository contains 3 release versions with specific semantic version tags. Each release maps to a version of the Terraform module. For demo purposes, the module creates an AWS network with a VPC and subnet. Hence, OIDC integration with AWS is configured. The IAM role is created and its ARN is used in the Terraform variable set. This Terraform variable set is associated with a Terraform project. Workspaces created within this project have access to these variables and can deploy resources in AWS. We create 3 workspaces, each using a different version of the module. These workspaces are VCS integrated with their own GitHub repository, with Terraform code using the specific module version. We then configure 3 Terraform teams with read access to the respective workspaces. Each team has its own Terraform user with an email address. This allows us to validate that emails are sent when a change request is created. As part of this demo, the Terraform code in this GitHub repo is used to bootstrap parts of the architecture, leaving the remainder for us to complete in the demo, so that we understand how the pattern works from the UI. If you are interested in full end-to-end automation, drop a note in the comments. The bootstrapped architecture is shown here. In this diagram, we create only one release and integrate that with the Terraform module. The bootstrap code also comes with the AWS OIDC integration, Terraform project, Terraform teams, and GitHub repositories containing the code for each workspace. We will be creating workspaces as part of the demo. To get started, this is the GitHub repo containing code for the module. The code shown here is for a simple VPC and subnet. The GitHub repo has one release with tag v1.0.0, as you can see in the orange box over here. A Terraform module that is deployed using the tag-based workflow has a version that matches the release tag in the GitHub repository. Again, we see v1.0.0 over here in the orange box. As part of the bootstrap code, a Terraform project named Demo Project was also created with a variable set that has the required variables for AWS OIDC integration, allowing us to deploy resources in AWS using dynamic temporary credentials. We will be deploying workspaces within this project. The bootstrap code also creates GitHub repositories for each workspace with Terraform configurations using different versions of the module. This screenshot shows the code for the workspaces that uses module v1.0.0 over here. Let's now create a new workspace using the version control workflow. The bootstrap code comes with a github.com integration configured. You may also configure GitHub app integration. I'll choose github.com since the credentials I used to create this has access to the GitHub repositories that were bootstrapped. Choose the GitHub repo for v1.0.0. Review the settings and create. We see the workspace is now created and we can start a new plan. Once the plan is created, we can review the plan and apply the workspace. This creates the VPC and subnet based on module v1.0.0. Now that we've created version 1.0.0 and a workspace that consumes it, let's create module version 1.1.0. In this version, we introduce a new optional variable named enable DNS hostnames, as you see over here. This gives module consumers the option to enable or disable it by changing the Boolean value. It defaults to true, which is the current behavior that existing module consumers experience. Since this is a new feature that is backward compatible, we will tag it as a minor release. Tag the release as v1.1.0 and describe it before publishing the release. The new release is now published and we can see the release notes over here. The Terraform module automatically detects the new release and we see the version as 1.1.0. Review the bootstrap GitHub repo for the workspace that will use module v1.1.0, as we see the version is over here. We'll create a new workspace referencing this repo. Review the settings and then create. We see that the workspace is now created and we can start a new plan. Once the plan is created, we can review the plan and apply the workspace. This creates the VPC and subnet using module v1.1.0. Now that we've created module version 1.1.0 and a workspace that consumes it, let's create module version 2.0.0. In this version, we refactor the variable cider_block to vpc_cider_block. Changing this variable requires module consumers to also change the variable they pass to the module. Since this is not a backward compatible change, we will tag it as a major release. tag the release as v2.0.0, describe it, and publish it. The new release is now published. The Terraform module automatically detects the new release, and we can see that the version is 2.0.0. Now we have 3 module versions. Review the Bootstrap GitHub repo for the workspace that will use module v2.0.0. Notice that we are now passing in the variable as vpc underscore cider underscore block. Now let's create a new workspace referencing this repo. Review the settings and create. We see the workspace is now created and we can start a new plan. Once the plan is created, we can review the plan and apply the workspace. This creates the VPC and subnet based on module v2.0.0. We now have 3 workspaces using different versions of the module. In the next part, we explore the effects of deprecating and revoking modules. Back in the Terraform private module registry, recall that our module has 3 versions. Select version 1.1.0. Now that we have changed the selected version, click on Manage Module for Organization and choose Deprecate Module version 1.1.0. Provide a reason for deprecating the module version, and we can also add links to additional information as well. For this example, I've added a link to the GitHub repo for the v2.0.0 release. The Terraform module now shows that version 1.1.0 is deprecated. Navigate back to the workspace that is using v1.1.0. Starting a new run now shows a warning that the workspace is using the deprecated module. It also shows the custom message and link that we added when deprecating the module. If there were changes in the Terraform configuration, an apply can still proceed even if the workspace is using the deprecated module. Now let's test creating a new workspace using the deprecated module. Here, a new workspace is created using similar steps to what we did previously. Choose Start New Plan. The plan works and shows the resources to be added. There's still a warning that the workspace is using the deprecated module. At this point, reviewers can either cancel the run, or they can continue using the deprecated module. There might be a valid reason for it. For example, maybe a QA team is testing whether upgrading the version from a deprecated version to the latest version results in unexpected resource deletion. Now let's see the module version revocation behavior. To revoke a module, we must first deprecate the module. Back in the Terraform module registry, change the version to 1.0.0 and click Manage Module for Organization. Choose Deprecate Module version 1.0.0. Enter a reason and a link. The module now shows that version 1.0.0 is deprecated. While still viewing version 1.0.0, click Manage Module for Organization. Choose Revoke Module version 1.0.0. Enter a reason and a link. This will show up in the run output for module consumers who are using the revoked version. And then choose Revoke. The Terraform module registry now shows that version 1.0.0 is revoked. Navigate back to the workspace that is using v1.0.0. Starting a new run shows a warning that the workspace is using the revoked module. It also shows the custom message and link that we added when revoking the module. If there were changes in the Terraform configuration, an apply can still proceed even if the workspace is using the revoked module. Now let's test creating a new workspace using the revoked module. Here, a workspace is created using similar steps to what we did previously. Choose Start New Plan. This time, when a new workspace uses the revoke module, it results in a plan error. This indicates that new workspaces cannot use the revoked module. Module consumers must make adjustments to fix the error. We can see how revoking a module version prevents new users from using it. The next part of the demo involves setting up Terraform teams and notifications in preparation for using change request notifications for teams that own the respective workspaces. The Bootstrap code creates 3 Terraform teams, one for each of the 3 workspaces. Each team comes with a default email notification configuration. The default email configuration sends notifications to all team members for all workspace events. You can also choose to create custom notifications which supports other destinations like Webhook, Slack, and Microsoft Teams. You can also specify specific workspace events to receive notifications for. As of this recording, the only available option is change request. Navigating back to the workspace shows that it does not have any team access granted. So this is for workspace v1-0-0. Let's click Add Team and Permissions. We choose the relevant team that matches the name of the workspace. This is created as part of the Bootstrap code, and grant it custom read-only permissions. This associates the team to the workspace, allowing the team to receive notifications on this workspace's events. Verify that the workspace now has team access granted to the team named workspace v1-0-0 with custom privileges. Repeat the same steps to grant the team named workspace v1-1-0 access to workspace v1-1-1-0 module. Finally, we do the same for workspace v2-0-0. At this stage, we have 3 Terraform teams. Each of them has custom read access to only a single workspace. As part of the Bootstrap code, we create Terraform team members for each team with a unique email. HTTP Terraform invitations will be received for each of these emails. This allows us to test how change requests on a specific workspace results in notifications sent to members of the team associated with that workspace. As you can see here, the email addresses are all different. For each of the invitations, we will create a HCP account. Once the account is created, we can accept the organization invitation. The invited team member now sees the organization as one of its organizations. View the organization's Terraform users and their associated Terraform teams. There are 3 Terraform users, each are members of a different team. At this stage, we have granted each team access to one workspace only. Each team also has a single Terraform user with a unique email address to test receiving email notifications using the default team notification configuration. What we have done for this part is summarized in the diagram shown here. In this final part, we'll use the Explorer to find workspaces that are not using the latest module version, and then create a change request for these workspaces. When a change request is created, notifications will be sent based on the configurations done in the previous part. The Explorer gives us the option to select by type or view pre-configured queries based on specific use cases. Let's see what the module's type shows. Clicking modules shows details like the source of each module version, the number of workspaces using a particular version of the module, and which workspaces are using that version. Clicking the Workspaces view shows various details about each workspace. Information includes which project the workspace belongs to, its run status, the module count, which modules are being used, and information about the provider. There's other information available, and I encourage you to check it out. We can add filters to narrow down the search. In this case, it is narrowed down to which workspaces are not using the latest version of the module, and which has a run status of planned and finished. This results in the original two workspaces that are using the deprecated and revoked module versions. Selecting the checkbox next to the workspaces reveals the Create Change Request button. Click this button. This leads to a change request form where we can fill in the subject and the message describing the requested changes. We can then choose Create Change Request. Navigating back to the workspace that is using the revoked module shows that there is one change request. Clicking that shows the change request subject and message that we entered. If we click into this, we'll see the formatted change request. At the same time, an email is also received by the team member of the team that has read access to that workspace. This shows that we have a proactive way of informing the respective teams that they must upgrade their module versions. We repeat the same for the workspace using the deprecated v1.1.0 module version. We see that there is also one change request. We can view the change request, and again clicking into it shows the formatted change request. The team member that has a different address now also receives an email based on the change request created for workspace v1-1-0. This shows that notifications can be targeted to specific teams that have been granted access to the workspaces that need attention. That's all for the demo. Thank you, and let me know in the comments if you have any questions.
Yeah, amazing session by Glenn. I think Terraform workspace and Terraform modules and lifecycle management is an integral part, right? And I think the way he explained with demos, I think it is very good to see because you can actually see it in action, right? So great work by Glenn. Any thoughts on that, Neil?
Yeah, to learn from the person working at HashiCorp is a different thing because he had actually implemented all the things there and he actually knows the product better. And
Yeah,
the
yep.
techniques were very, very much on the point and where they are and they can be implemented in real world everywhere.
Yep, makes sense. So I just have one announcement. I think I saw someone in chat mention about how can they basically apply as a speaker. So HashiTalks 2026 is coming. So it is the eighth annual 24 hours virtual event by HashiCorp. It is on 19th and 20th of February, and the CFP for that is open. So you can visit the hashi.co/HashiTalks 2026 to register and submit a talk at the HashiTalks 2026. So I would really encourage people who are learning about HashiCorp or maybe who are working on HashiCorp products like Terraform, Vault. They can just submit a session and be part of the HashiTalks 2026. Um, Over to you, Neil, on the next speaker.
Yeah. So as we were discussing on the HashiCorp user group and ambassador previously, so the next speaker is a HashiCorp ambassador and also running a HashiCorp user group. So let's welcome Mahendra. He will be discussing on Vault Radar, HCP Vault Radar. So the main concern here is how we manage secrets. So he will discuss the best practices on managing the secrets with HashiCorp Vault Radar. So let's welcome Mahinder. Over to you. Yeah.
Hello everyone. Welcome to HashiTalks India. Thanks for joining my session in HashiTalks India. I am Mahendran Selvakumar. I work cloud and DevSecOps engineer at Tata Consultancy Services, and I am the HashiCorp ambassador and West Midland HashiCorp user group organizer, and also that AWS community builder and AWS ambassador. In this session, what we'll learn, so I'm going through about that HCP Vault Trader, how we can manage that multiple multi-cloud secrets in that HCP Vault Trader, and how do we use that HCP Vault Trader, and also how we can use that latest things from HashiCorp, so like Jira scanning, and also that Visual Studio Code extension for HCP Vault Trader. What is HCP Vault Trader? So HCP Vault Trader is a managed service from HashiCorp. So using that HCP Vault Trader, we can able to discover, access, and remediate that leaked secrets and unmanaged secrets. So if you are using the code, so you can able to manage that you can able to use remediate that unmanaged and leaked secrets in your code. Not only in that remediation and discover and access, we can able to get that real-time visibility also using the HCP Vault Trader. So in that HCP Vault Trader, we can able to integrate with that HashiCorp Vault. So if you integrate with the HCP Vault, so you can able to detect that fixes early and without slowing down your development. Why HCP Vault Trader? So so using the HCP Vault Trader, we can able to reduce the risk, and we can able to increase the speed, and we can able to lower the cost, because in the reduced risk part, so we can able to find and prevent unsecured secrets in that code or pipeline, or somewhere else in your organization. In the increase in the speed perspectives, we can able to manage that common code. I mean that, so multiple team codes and the multiple team conference pages and multiple team Terraform codes, multiple team S3 bucket, all the multi-cloud things, all they will be managing using that HCP Vault Trader. So not only in that reduce the risk and increase speed, we can able to lower the cost also, because using that false positive and wasted effort, so we can able to reduce that lower cost as well. So how it works in that HCP Vault Trader. So first, HCP Vault Trader discovered that tool. So whether it's in the GitHub or GitLab or AWS, Terraform, Azure, or pipelines, it's first discover it. Once it discover it, it analyze that hard coded password or public secrets or exposed overexposed identities wherever it is available. So it will analyze that one. Once it's analyzed, it will classified that based on that identification, whether it should be AWS path, AWS secret ID, or passwords, or GCP, or vault tokens, or database credentials. It will classify that. Once it's classified, it will suggest that revocation and rotation as well. So if we integrated with that vault, it automatically rotate that secret as well, and also we can able to restrict and delete that access as well. So on after remediations, we can able to report that. So in that HCP Vault Trader, we can have that dashboard. Using the dashboard, we can able to view that, so what are the scans, what are the things will be available, so whether it should be medium or critical or high priority risk. So we can able to do that, and also we can able to trial and complaints, team complaints as well in the HCP Vault Trader. So what are the things HCP Vault Trader can? So HCP Vault Trader not only scan the secrets, it scan that personal identifiable information. So whether you have given in that any of the personal identifiable information, like that email ID or your credit card, some other details in your code or somewhere in that data sources, HCP Vault Trader detect that as well, and also that it will detect the non-inclusive language as well. So it will prevent those things. So because it's deeply scanning in that secrets, PA, and non-English languages. What are the scanning methods available in the HCP Vault Trader? So in the HCP Vault Trader, there are three scanning methods available. So one is that HCP Vault Trader scan, and another one is HCP Vault Trader agent scan, and another one is HCP Vault Trader CLI scan. So in that HCP Vault Trader scans, we don't need to configure anything. We don't need to manage anything, because HashiCorp will manage everything. So we don't need to pay for the running cost as well. So we need to pay only how many resources, data sources we are using. Based on that one, we can able to pay. And another one is the Vault Trader agent scan. So in that Vault Trader agent scan, so we need to manage that one. So we need to create that agent pool, and we need to configure all the things for the Vault Trader agent scan. And next one is that Vault Trader CLI scan. In the Vault Trader CLI scan also, we need to install the Vault Trader CLI in your local machine or a server or somewhere where you are configured, and you can able to configure the data sources like Terraform, yeah, Amazon S3 and Docker images and GitHub Actions and pre-commit, all the things you can able to configure using the Vault Trader CLI. The next one is what are the data sources supports in the HashiCorp Vault Traders. In the HashiCorp Vault Trader, we can able to see that. So we can able to scan that GitHub Cloud and GitHub Enterprise and GitLab and Bitbucket and Azure DevOps and Confluence and Jira Cloud and Jira Server. So in this session, so we'll see about how we can integrate with the Jira Cloud as well in that demo. So these are the integrations we can able to. So not only in the scanning, so we can able to integrate with that alerting and ticketing system and monitoring system as well. So we can able to integrate with that Jira in Jira or Slack or Microsoft Teams or Badger 2D or ServiceNow or Splunk. So using the tools, we can able to get the alerts. So whenever we are getting the risk, and whenever when anyone added that credentials or AWS access key or secret key or passwords or Azure key, secret tokens, all the things we can able to integrate with the tools. So based on that integrations, we can able to get the alerts and we can able to remediate immediately. In during the HashiConf 2025, HashiCorp announced that Jira Vault Trader Jira scanning as the general availability. So in that case, we can able to scan the Jira tickets or Jira dashboards, and if anyone added in secrets in the Jira tickets, comments, and attachment, we can able to find that as well. And not only in that Jira tickets, we can able to scan that Confluence pages as well. So Confluence page and other things as well. So in that Jira scanning methodology, so we can able to scan that new projects on existing projects as well. So whenever sensitive data is exposed or shared, so we can able to get that alert, or we can able to detect that easily, and we can able to fix that easily. So using that Jira scanning, so we can able to protect our teams before the issues arrive. So next thing released by the HashiConf, so Vault Trader VS Code plugin. So this Vault Trader VS Code plugin available in the public beta. So now you can able to use that feature, and you can able to how the HashiCorp Vault Trader VS Code plugin will be working with your code. So using that Vault Trader VS Code plugins, we can able to detect that secrets real time, and in that if you are giving anything in your code as the hard coded, so you can get the feedback immediately. So you can able to view that feedback. So we'll see in the this also in our today's demo. And next thing is that say it will be highlighting that one. So wherever you are given in that user passwords or credentials or secret key or access key and AP key or token, it's give the highlighting. So using that highlighting, we can able to click that one, we can able to see that values, and we can able to get the detailed score information. Is that high level of risk or medium or low on secret types, and also that we can able to check that whether it should be the active or not non-active. So for example, if you have ordered that AWS access key and secret key, if you check in that whether it should be active or unactive, so that also the VS Code plugin will share that information. And next thing is that actionable remediations. In that actionable remediations, we can integrate with the HashiCorp pods. If you integrate with the HashiCorp pods, we can able to copy that particular secrets with that HashiCorp pod, and we can able to remediate that as well. So next thing is the we will see the two demo. One is that how we can use a HashiCorp Vault Trader to scan the Jira, and other demo we will see that how VS Code plugin will use to detect that hard-coded passwords and secrets. So in this first demo, sorry. So I have logged in HashiCorp portal. So this is the HashiCorp portal. So most of us already know these things. So in the HashiCorp portal, so we can able to see that Vault Trader. In that Vault Trader, so here we can able to configure the data sources. So if you see here, here you can able to see that data sources. So now we are going to configure with that Jira Cloud. If I click the Jira Cloud, so it will ask that organization. In the organization, I will give the DevOps net, and also we can be able to give that password. So I have created that uh, trial Atlassian account. So in the trial Atlassian projects, we can able to get that one. And here we need that Atlassian API token. So for that Atlassian API token, so we need that API token. So now I am going to create that Atlassian API token. So in that API token, the name should be in that Jira underscore cloud underscore API underscore token. So I'll give that name. So once I can't created that API token, so we just need to copy that API token and paste it in that Atlassian API token in that HCP Vault Trader portal. Once I click it, just click that next. So once clicked it, it will validate how many projects you need to scan. So as of now I have one project, so in that case I will give that all active projects. If you want to specifically monitor in that some of the project, you can able to give that specific projects as well. It will take some time to scan our projects. Once it's scanned, so we can able to see that our projects here. So in that case, I have created that projects here I have created that DevOpsNet projects. In the DevOpsNet project, so I have created two types of tickets. One is that create RDS instance and create EC2 instance. So in the create RDS instance, I have given that access key ID, secret key ID, and that password. And also that in that EC2 instance creations, I have given that username and password. So we will show how it will be see here, you can able to see that correct. So it's configured for the data sources. So once the data source is configured, so we can able to see that. So what are the resources we have, it will be scanned, and what are the passwords and username it will be given. So here it will take taking some time to initial scanning. Once it's scanned, so we can able to see that data sources. So it will do that initial scanning. Since in the meantime, so we can able to see that correct. So here we can able to see that Slack integration. So because we are going to integrate with that Slack as well. So how we can integrate, so we can configure that Slack connection. So once we configure the Slack connection, so we can able to configure that subscription. And also before we can create that Slack integration, so we need to configure that Slack app for that. So in that case, so I'm going to create that Slack app. So if you go to that API, so you can able to see that Slack apps creation. In the Slack apps creation, so you need to choose that workspace. I have the dedicated workspace for my project. So here I have used the DevOps net, and I have given the text. So here it will be given as the demo JSON file. So now I'm going to configure that demo JSON. So here I have that code. So I got the code from that HashiCorp. Once I given that one, it automatically provide that values, and it already have that what scopes the particular things you'll need. So once I created, it will create that app. So if you see here, you can able to see that create app HashiCorp Vault Trader. So if you see here, we need to create that we need to install that particular application into that workspace. So here we need to choose that what workspace you are going. So here I have a channel called HashiTalks India Vault Trader demo. So once I given, so it will install that application to that demo. See if you see here, so here I have that HashiTalk India Vault Trader demo channel. In the channel, it has that applications correct. Well, now what we need to do, so in that if you click that particular app, so you can able to see that options add this app to the channel. So if you see here you need to choose that app. So once chosen, so here you can able to see that HashiCorp Vault Trader will be created. So once installed, so here we need that here BAT user auth token. So using that auth token, we will create that connections. So if you see here, now if you go to that data sources, it will take some time because it's discovering that active resources, and the meanwhile we will create that connection. So if see the connections, I will give that connection name as that Has- HashiTalks India, and here we need to give the bar token. So the bar token we got it from that Slack API, correct? So we can use that bar token here. Once give that, it will validate that one. So once create, so now the connection was created. Once we created the connection, we need to create that subscription. So for the subscription, we need to have that connection name, and also that we can use that subscription name. HashiTalks subscription. So I will give the HashiCorp subscription, and here you can able to give that what are the events should be filtered. So we can able to give that all events, and also we need to give that channel name. So in that case, our channel name is that HashiCorp India Wall Trader demo. So I will give that particular channel name. Once given, I will ask provide that test and save. So once it will be able to connect, so now we configure that both connection and subscriptions. In that case, now once we can able to see the data sources, we can able to get that particular integration. See here, now you can able to see that because this is a test message sent by HashiCorp Vault Trader to validate the channel information. So now HashiCorp Vault Trader send that test message. Okay, so here you can able to see that app. So in that app, we can have the HashiCorp Vault Trader, and the particular app integrated with that our channel. So now the thing is that data I mean the data sources. In the data sources, we can able to give that Jira's cloud and other things, correct? So if you see here, just give a minute. Not, I will add again because I will revoke that one because the particular name should be in that command. So I will delete this one and recreate that. I'm not sure why it's throwing the error. I will copy that API token and paste it here. So in that case, I will give that only one project, because instead of selecting all the projects, I have given that only one project because we have that we have only one project in that one, correct? So it will take some time. So during that time, so I will show that uh, wall trader scanning extension. Here, if you see here, you can able to see that HCP wall trader scanning plugin. So if you see here, you can able to install that HCP Vault Radar plugin. So once you install the plugin, you can able to see the plugins here. Here you can able to connect that HCP Vault Radar VS Code plugins with that Vault. So as of now, I don't have Vault, so I don't connect with that one. But in that case, so we can able to see that how it will be provide that hard coded value, correct? Here we can able to give that access key and secret key values. So I already created that user. In that user, I will provide that access key. So in that access key value, I will show that save that value, and same the secret key. I will save that value. So as I said earlier, so it will show, it will highlight that value, and it will provide the detail, correct? See, it and the HCP Vault Radar plugin. So provide that. So because it's found that AWS access key ID, and also that this is the secret risk severity as that info, and it will provide that, and it shows there's no active connection configured with that vault. So because this also it's configured, and also here you can able to see that secret assessment. This one is that secret assessment. So here the particular thing will be that medium, the same thing. So here I have shown in that access key and secret key, correct? So in that case here I will show the database creation. In the database creation, you can able to see that username and password. If you see here, it will not highlighting anything, correct? So in that case, if I change that actual password, HashiTalks at 123, if I give that HashiTalks 123 and save, it will highlight. See, it will provide the highlight, and it will provide if you click there, it will provide the password assignment. So, and also that what is the risk type, on what is the password, it will be connected with that vault or not. So it will show all the things. So this is in the public betas now. So you just need that Vault Radar HCP Vault Radar license key. Once you added the license key with that HCP Vault Radar extension, you can able to see that, and you can able to detect that. So in case if any of the developer or any of the team using that secrets or any access key secret key in that code, so we can able, and we can able to fix that as well. See, if you're using vault, so you can able to copy to vault as well. So because this also you can able to using with the HCP Vault Radar plugin. So now I will check in whether its data source is configured. Yeah, now if you see here, now the HCP Vault Radar, so that a particular data source will be configured. So if you see here, the DevOps need data source will be configured. So here, if you see here, you can able to see that what are the things available. So whether it's the medium or critical or high. See, if you see here, you can able to see that one. In that case, if you click that particular workspace, so if now I'm going to see that projects, correct? So now I'm going to clone that particular task. See, if I see here, I will clone that particular task, and now here I will give that create DynamoDB. So I have created another task. If you see that HCP Vault Radar, so it automatically scan that one. So it automatically scan that what will be happening. So in that one, so it will scan all the things, and it will provide that particular Slack integrations to that channel. See, if you see here, now we added that passwords, correct? In the particular, see, if you see here, if you click that findings, it automatically routing to that particular password. So now we have created the create DynamoDB instance. In the create DynamoDB instance, I have given that username and password. So it will detect that one. It will automatically send the notification to that Slack channel. The same like that. So we can able to give that RDS instance. So I will clone this one. In that task, I have given that access key ID and secret key ID. So I will clone this as well. Here I will give that create ECS cluster. So for example, I will add that sample tickets. In the sample ticket, I have given that create addition something. So in that case, it will detect that particular secrets, and it automatically send that notification to that Slack channel. So if you see here, so once it's scanned, once it's detected, we will get the alert here. See, if you see here, we will get the alert for the DevOps 10. So our task is the DevOps 10. So in that case, if you see that findings, it's automatically see, this is the task we created. So in the task we given that access key id and secret key id. Here if it automatically notify to that Slack channel. So based on that Slack channels, we can able to identify that secrets. So not only this thing, so we can able to integrate with the other services as well. And we can able to see that scans details as well. So whether it should be that medium or high or critical. So if you see here, you can able to see that 5 critical and 9 high and 5 medium. So these things also we can able to, and we can able to do that non-inclusive also language and PA data as well. That's all for this today's session. Thank you again for joining the HashiTalks India talk. So thanks everyone. So if you have any questions, if you want to try in that HashiP Vault Trader, you can able to try with that one. And if you want to have any questions or anything, you can able to think. So these are the QR codes of my LinkedIn blogs and my HashiCorp user group. In my HashiCorp user group, we are organizing that in person and online events as well. If you can join that online events, if you are anywhere, and we will provide that some HashiCorp certification voucher as well. So you can join that HashiCorp user group, and we are planning some giveaway and swags and as well. So if you are around that Birmingham or West Midland region, you can attend that in person meetups, or else we can join in that online events. So thank you all. Thanks for the opportunity, and thank you HashiCorp.
Yeah, I think thanks, Mahendra, for an amazing talk. I think HCP Wall Trader is an amazing tool. Just recently, I saw about a news article that Jaguar Landing Rover, the company manufacturing unit, right? They faced a issue with Jira leaking their secrets, which caused some production issues, right? Now, imagine if they were using something like an HCP radar, right? Their Jira secrets, whenever they were maybe leaked or maybe they were available openly, then they could get this notification via Slack or something, right? And they would have to basically act on it, right? So I think this is a very good tool and great demo as well by Mahinder. Uh, Neil, any thoughts on the session?
Yeah. So this is very cool and very new in the market, but very good
Yeah, I
because a lot
think
of people use Jira, use Slack in day-to-day life.
yeah, makes very like it makes a lot of sense. I think to use this kind of tools. Just one reminder that if you are looking at this sessions or you are live at right now, you might have probably maybe missed one or two sessions. Don't worry, these sessions will be uploaded to YouTube later on, so you can catch them out later as well. The presentation slides are at discuss.hashicorp.com. So maybe just go over that and just check out the slides if you are interested. And I think with that said, I think Neil, let us know introduce the next speaker.
Yeah. So moving on to boundary, like not a lot of people use that, but we hadn't talked this time. So yeah, let's move on to boundary.
Okay, I think
Speaker,
there is
Rajni. She's expert in DevOps and have been. Hi, am I audible?
yeah, Neil. There is some background or maybe there's some glitch. You are not really audible. There's some movement. So I'll just introduce the speaker. No worries.
Yeah.
So yeah, the next speaker that we have is Rajni. She is going to be taking a topic about vault and boundaries. So zero trust architecture is super important nowadays. And how do you ensure zero trust architecture with vault and boundary? That is going to be the topic for Rajni. So over to you, Rajni.
Hello, guys. Good afternoon to all of you. So, this is what I'll be talking on. So, you can see the topic here: Zero Trust Architecture with HashiCorp Vault, Boundary, and Docker. So, we'll be talking about multiple tools here. So before getting into the discussion, the session, I would like to introduce myself. So my name is Rajni Ekundi, and currently I am working with Okta as a senior site reliability engineer. And apart from that, I am a Docker captain as well. So I was selected as a Docker captain last year because of my contribution to Docker community. And I am a WTM ambassador as well, and international speaker as well. So this is all about me. And next slide, you can see here, this is gonna be the agenda. So you can see multiple points I have mentioned here. So we'll be starting from the very basic, like what exactly is the topic, and how the security aspect has been shifted from these many years. Okay, and what is zero trust architecture, what exactly we are meaning when we are saying zero trust. And we'll be talking about multiple tools like HashiCorp Vault, Boundary, and Docker as well. So a lot of things we'll be discussing here. So this is the very first slide we do have, and you can see multiple points are being mentioned here. So we'll be starting with the very first block that we can see here, which says zero trust is not equal to zero access. So this is what the first point here says. So zero trust basically doesn't mean zero access at the first place. So this basically means nothing is trusted by default. The multiple users or multiple applications or different services that you are using, so they must prove their identity before they are getting in, or if anyone is trying to access the same. So we can say that instead of depending on any like firewalls or network zones, we can continuously rely on the continuous identity verification, or we can go ahead with the policy based control for the every single request that is coming into your application or your service. So this is what basically the first point says here. Then we can talk about how exactly this modern infrastructure is little complex than if we are comparing the same with the containers, the APIs, or the multi-cloud setups, or like we are having these all different things if we are talking about the modern infrastructure. And these all things are making the infrastructure complex, and this is eventually going to increase the attack surface. And that's why we need a very dynamic secrets kind of methodology, or we need to opt for short-lived credentials rather than going ahead with the long-term passwords, which we basically tend to hard code into the systems. And again, if we are specifically talking about security, okay, so security definitely can't be an afterthought. It must start at the build pipeline itself, basically by shifting your security left. So this is how we are embedding the different checks or the secret managements at the very early stage, and this is how it is going to help us to reduce the vulnerabilities. And in short, we can say that zero trust is all about continuous verification, and it's all about least privilege access, and we can say it's all about how we are making security a part of every action, whether it is human or it is machine, and whether it is across all the users, containers, or the entire infrastructure. So this is what this first slide says here. Going ahead with the second slide, so we have here what zero trust means for containers. Okay, so if we are talking about containers, so containers are nothing but they are the running instances of the applications. So this is a very short definition we are having. And containers are very fast moving, they are short lived, and they are dynamic in nature, which makes traditional security models which are based on these static keys or long-term tokens very ineffective in nature. So but the same thing if we are talking about a zero trust setup. Okay, so in this setup, every container that you are having, so that every container is gonna have its own short-lived and kind of identity based credentials instead of the shared SSH keys or any other passwords and stuff. And if we are specifically talking about Vault here for secret management purposes now, so Vault is going to play a very central kind of role by injecting dynamic secrets at the runtime. So nothing which is sensitive in nature is gonna be hard coded into the Docker files or into the configurations that you have. And fourth point we have here is of the boundary for access control. So boundary on the another hand is going to add another layer by managing who can access the container and for how long and under what particular policies they can access the container. So this is what basically be taken care by boundary here, and these all things are exactly are helping us to enable the JIT access, just-in-time access, without exposing the internal network that we have built for the infrastructure. And together, Vault, Boundary are gonna bring identity, secrets, and access management into one single workflow. So this is how this approach is gonna keep your containers isolated, your credentials short-lived, that is basically temporary, and how you can access your entire either its application services in a very secure manner. And this entire thing is going to make your containers very secure, not just practical but automated way as well. So going ahead with the third slide which we have here is what are the different challenges that we face in containerized environments. Okay, so multiple points I have mentioned here, so we'll just go ahead with all these. So as we discussed in the previous slide, how containers are short-lived. Okay, so containers are basically very fast, temporary, and they have this nature of constantly changing, which makes these traditional security models like static keys or the fixed networks very ineffective in today's complex and dynamic infrastructure. And every container that you'll be spinning up, that is going to create a new endpoint, and it will be creating new identities to manage, and this is eventually gonna increase the risk of misconfigurations and unauthorized accesses if you have if you're not handling these all things properly. So that is going to eventually end up in a mess. And again, suppose if you are having multiple secrets for your containers such as API keys or SSH tokens and different environment variables, so these all often end up in a very scattered manner across different images, different repositories, and different pipelines. So this is what is going to lead to what exactly we can call here as secrets sprawl. So that is another challenge we have here. And again, if we are talking about shared credentials, and we can talk about inconsistent IAM policies as well. So that is basically related to the access control drift here. So this is gonna cause access control drift, and where if this is gonna be very difficult to trace who exactly accessed what particular thing and when they access this. So keeping a track of these all things is gonna be really very big trouble. And to secure your containers in a very effective manner, we need to make sure that we are following the zero trust approach, and we are taking care of all the dynamic secrets. We are following the strong and very strong identity verification process we are following. And again, we are going ahead with the automated access control way that is going to adapt to multi-cloud and distributed environments. Okay, so this is the next slide we do have. We are now talking about what exactly is HashiCorp Vault, and more like the features and what is the problem it is solving. So multiple things we'll be talking here. So entering into HashiCorp Vault now. So Vault is gonna bring the zero trust model to a life, basically by managing the different secrets in a dynamic nature. And instead of relying on the static passwords or the static tokens, every credential or every password that is being generated, that will be generated on demand for every new session, and automatically that will be expired once the session is gonna end. So this is what exactly HashiCorp Vault is gonna do. And Vault will be eliminating the need to hardcode the secrets in Docker files, or the scripts or the pipelines, and this is going to reduce the chance of accidental exposure of your passwords into the code repositories. So that is how it is eliminating the need of the hard-coded secrets. And again, Vault is going to use fine-grained access control, which is going to define exactly who can access what particular service and at what particular time. And this is going to be integrated very smoothly into different identity systems, like take an example like Okta itself or Azure AD or GCP. So multiple identity providers are there. So it's very easy to basically create a blend of these different identity providers and Vault. So talking about the scalability now here, so Vault is gonna scale very easily across multiple clouds and multiple container environments, injecting the secrets very securely into Docker or Kubernetes at the runtime. So this is all about HashiCorp Vault. So let's go ahead into the next slide, that is HashiCorp Boundary. This slide is going to be all about HashiCorp Boundary now. So HashiCorp Boundary is going to completely change how your teams are accessing the infrastructure by removing the need for VPNs or any kind of shared SSH keys or jump hosts. So multiple things are there. So Boundary is going to replace the same with identity based and time bound sessions that are gonna be verified and logged automatically. So every user or every service that you'll be dealing with, so they will be authenticated first, and they will be granted the JIT access, just in time access. So that basically means that they can connect only when needed, and at that particular once you're done with the job, that particular access is gonna end the moment of the session, once you're closing the session. So this is how exactly Boundary is gonna work. And talking about the integration of the same with the multiple identity providers, okay, so Boundary is going to integrate very seamlessly with the Okta, Azure AD, or GCP IAM. So multiple identity providers are there in the market, and you can easily create an integration of the same with Boundary. And this is going to ensure all the permissions are tied directly to the verified identity providers directly. And Boundary again is gonna prevent like your credential exposure by never revealing your actual SSH keys or your actual network endpoints to the users. And one more thing I can talk about here, Boundary, is like every session that is gonna be producing the detailed audit logs, and it is also will be giving you the full visibility into who connected, for how long they connected, and what they need. So these all things will be having a record. So this is how again Boundary is going to be really playing a very important role here. Okay, so coming to the next slide now. So this slide basically is talking about how we are talking about Vault, Boundary, and Docker, creating integration of these multiple roles here. So first thing we can talk about here is zero trust is on the diet, automation, which of course automation is considered, and the access will not be given by default, but it is basically crafted, then verified, and then it is revoked also dynamically based on the time and the users and stuff. So if we are talking about containers and the users, so they will interact with each other only when the identity is going to be confirmed, and the interaction will never happen through the permanent trust. So this is what exactly we are doing here by creating a blend of these different tools. And Boundary is going to deliver dynamic access control by creating identity based and short lived sessions, and user will be never able to see the actual SSH keys or the direct endpoints, everything that is happening. So that will be happening through a secure and a temporary channel. So that is the magic of Vault and Boundary. And Vault again is gonna power this entire thing of having short-lived or the ephemeral secrets delivery, basically by injecting these short-lived credentials into your Docker containers at the runtime, and that will be removed. That will remove the hard-coded passwords and tokens from the image or any kind of repos of the code. Then we can talk about automated policy enforcement here. So automated policy is going to ensure consistent rules across all clusters and environments. So once you have configured your access control is going to be enforced automatically. That is going to reduce the human errors and any kind of misconfigurations as well. And continuous verification we do have here. So every session that is continuous, every session that we'll be creating, so that will be continuously verified, not just verified but authenticated and audited. So this is going to give you a complete visibility into who accessed what and when they did access this. So this is going to maintain a compliance and observability too. And basically, what exactly is the main conclusion here for the topic? So zero trust integrity we wanted. So that is also we are achieving here by making use of Vault, Boundary, and Docker as well. So this is all about this particular slide. Next slide we do have is securing the build pipeline now. Okay. So zero trust is gonna start right at the build stage, of course. So it won't start after the deployment, but it will start at the build stage itself. So the goal here is to make sure that every image, every dependency, and every secret is verified and it is secured before it is even reaching the production. So this is the main goal here. And Vault is going to inject short-lived credentials directly into your CI/CD pipelines during the Docker build stage. So that no tokens, passwords, or the keys are hard-coded into the source or the image. Talking about Boundary here, so Boundary is gonna add another layer basically by enforcing your policy-driven pulse, and so it will take care of only verified and authenticated identities are capable of triggering or modifying the build process. So this will also be taken care by the Boundary. Again, we do have multiple tools in the market, like we do have Trevi, we do have Docker Scout, which are helping us with automatically scanning the Docker images for vulnerabilities. And they will again ensure compliance with security baselines and CV thresholds before release. So together, HashiCorp, Vault, Boundary, and Docker, and the different scanning tools we do have in the market, so we can build a zero trust pipeline, which is going to help us to if we are talking about security, integrity, so everything will be taken care here. Then this is the next slide we do have here, developer access flow. So the developer workflow is in a zero trust setup is going to start with the identity verification. So this is going to be the first step. Okay, identity verification. So developers are directly going to authenticate through SSO providers like Okta or GCP-IAM or Azure AD. So there are no shared keys or no shared VPNs or static credentials are provided. Then we do have JIT access, just-in-time access. So once you are done with the verification, Boundary is going to provide you just-in-time access. So this means developers get temporary sessions that are going to open only when needed and close automatically afterwards. So no leftover permissions are going to be provided here. So Vault is going to deliver short-lived creds in a dynamic nature directly into the developers' environments or during the container runtime, and it is going to remove any need for store secrets or tokens as well. And every session and every action is going to be logged in a real time, providing you a full audit visibility like who accessed what, when, and for how long they access the service or any other thing. So this is the flow that we are having, the developer access flow, and this flow is going to keep the developer's experience very smooth while maintaining complete control and traceability. So combining basically the productivity with your zero trust security principles at the very access point. So this is what exactly the flow is going to be here. So that was all the session from my side. I actually had a live demo for this particular session, but there was an emergency at my end, so I had to pre-record the session, and that's the reason I am not able to do the demonstration right now. But if you have any questions for this particular session, you can definitely scan this QR code and you can reach out to me on LinkedIn. And I do have some files as well, the demonstration files. So that files again I can provide you guys if you are interested into the demonstration. So that was all about this particular session. So thank you so much. Thanks for this opportunity, HashiCorp India team. Have a good day ahead.
Yeah, hi. It was an amazing session. A lot of insights on boundary and world. And now we have Sharonan who has joined us in the stream. You can introduce yourself, sir.
Yeah. Hi, everyone. And happy to meet everyone in HashiTalks India 2025. It's amazing to see our community come together again. And it's great to see developers, DevOps engineers, cloud engineers, and platform engineers who can make cloud adoption actually happen. So this is Saramnan, one of the HashiCorp ambassadors from India and founder of tech startup Cloud Engine Labs. And I'm happy to join as a co-host along with Neil and Ajit for this edition of HashiTalks India. And today's lineup looks great, and it's a reflection of IAC spirit HashiCorp has, and real practitioners sharing how they have used HashiCorp tools to build resilient systems, scale teams, and simplify their workflows.
Yeah. And HashiCorp user group is spanned across the world. So if you want to visit any offline event, so there are 65 plus countries with across 60,000 HashiCorp users across 190 chapters. And also in India, there are 19 HashiCorp user group chapters in India. So if you want to join any of them and do attend the offline sessions, do visit hashi.co/hugs to find a chapter near you and do visit the chapters and attend the events. Would you like to introduce the next speaker, Shonan?
Yeah. So before that, let's talk about the previous session. Basically, previous session actually talks one of the important ideas HashiCorp has, which is a part of security lifecycle management. Under security lifecycle management, there are few tools HashiCorp has, which is Vault, Boundary, and Console. In the talk, actually, Rajani has covered the important tools like Vault and Boundary, right? So it is about the zero trust, and it was very insightful session, Neil. And what do you think about that session?
Yeah. So it was very impactful and real world use cases because a lot of people nowadays use Vault because
Yeah.
you can have multi crowd secrets at a single place, and that is very much helpful for everyone in real world scenario.
Exactly, and security being the one of the pillar for the industry now, right? So because everyone moving towards agentic systems and GenAI app development, along with the traditional app development, security should be considered as an important element of it, right? And if I have to add a few more elements about HashiCorp overall product idea, they also have a idea called infrastructure lifecycle management. And today's session also cover predominantly the major tools that comes under infrastructure lifecycle management, like Terraform, Packer, and Waypoint, Nomad tools as well. Right? So that is actually a very important aspect of it. So basically, like what HashiCorp does is day zero developer does the development, and all these tools comes in on day one and day two operations, and with easily enabling the developers day zero operations as well with along with the automation, right? So that is the key aspect of having ILM and SLM in HashiCorp arena.
Yeah, absolutely, absolutely. You've been pretty much involved with the HashiCorp tool, right?
Yeah, correct. So I've been using like the HashiCorp tool, especially Terraform, from the year 2014, even
Oh,
before
nice.
it was version one, right? So I am very much well into like infrastructure as a code using Terraform, and I have created infrastructure automation in different cloud providers, as well as I am also good at developing custom providers as well.
Nice, nice.
Yeah. And I think it's time to introduce our next speaker, right?
Yeah.
So next speaker is Selvam, right? So Selvam is going to talk about the topic about managing infrastructure complaints using Open Policy Agent and Terraform. So Selvam is a seasoned DevOps consultant with over 11 plus years of experience in the technology industry. He has a strong background in DevOps, cloud infrastructure, and brings in wealth of expertise on the table, right? So he is also a community enthusiast and running user group in Madurai, I believe, and he also actively contributing to the community as well through his blogs and videos.
Yeah, thank you guys. Thank you so much for the warm welcome. So, so this little bit intro about me. So first of all, hello everyone. Thanks for joining this raining day. Oh, sorry, not too much rain today. So today is very sunny. Like thanks for joining at HashiTalks India 2025. So my name is Selvam Raju. I'm working as a development engineer for at Comcast, and I am a CNCF enthusiast. Also, I have explored ASICA tools like Terraform, Vault, Backer, and Vackern, and some other tools as well. And also, I'm a CNCF enthusiast, as I told. Like I'm exploring these CNCF tools and cloud and DevOps. I'm writing a blog about all those. So if you want, you can check it out by Medium blog as well. So I will ping my Medium link into the chat later. So this is a bit intro about me. So today I'm very excited talking about how to manage infrastructure complaints effectively using Open Policy Agent and Terraform. So this is the topic I'm going to talk about. So this is the agenda. It seems like what are the complaints challenges are there in IAC, particularly in Terraform, and what is policy as code, and what is Open Policy Agent and Rego, and after that we're going to discuss about how to integrate OPA with Terraform, and also I'm going to do live demo to enforce the cloud policies. One of the S3 bucket policy I'm going to live demo, and
Yeah,
also
hi, Selvam.
finally,
Yeah. Can you please put on the presentation mode, the full screen mode, the presentation?
yeah, sure. Is it fine now?
Still not like. Can you present the whole presentation? It's just showing the slides out.
Okay.
Maybe can you present, yeah, the full
Yeah.
screen?
Hi Silvam, can you press F5 please?
Okay.
F5. Yeah.
Yeah. Is it fine now, right? Okay, fine. Yeah. Sorry for that. Like today, this is the agenda I'm going to discuss about today. So first one is like, what is the complaints? What are the complaints challenges are there in IAC tool like Terraform or some other tools? And also, what is policy as code, and what is open policy agent, and what is Rego, and how we are going to write a policy. So this kind of stuff I'm going to do demo as well, and also I'm going to cover like how to integrate open policy agent with Terraform, and like finally I'm going to show you the some best use cases and what are the lines you have done. So these are the agenda which I'm going to cover today. So first one is like why complaints matter in IAC. seems like we are using many cloud, right? So for example, Terraform Cloud or AWS, Azure, GCP. So we have a lot of cloud platforms actually. So if any misconfiguration, that is a big challenge, right? So how we are going to find out the misconfiguration and how to mitigate. So these manual process is very tough to identify actually. So for that reason, there is a big complaints not in IAC. So first one is cloud misconfiguration and security misconfiguration like a public S3 bucket. So normally we don't expose our S3 bucket into the publicly. So we should use private. And also, for example, open security groups, which means like 0.0.0.0/0, which means open for all the posts. So that is a very big misconfiguration. So this kind of steps we should mitigate it, right? So this is a misconfiguration, for example, I'm given. And also manual review tone scale, which means like for example, we have 150 plus lines of Terraform code, right? So if the reviewing manually, that is a big challenge. So for that, that is doesn't make sense, right? So that is complaints not an IAC. And next one is like shift to left complaints direct airline, which means like before the deployment, we should mitigate the we should concern about the complaints actually. If any non-complaint settings are there before the deployment, we should mitigate it. Then we should publish the deployment. So these are shift-left complaints regularly and non-complaint settings like as I explained about misconfiguration and manual review, shift-left, this kind of stuff we should consider about that. And the next one is like a common IAC complaints pitfalls, which is like missing mandatory tax. So tax should be tax is like very important actually. Why means like for cost allocation or ownership or going to apply any settings for the particular resources means if we have tax, we can easily apply using the tax. And public S3 buckets should be avoided. And unencrypted storage, which means we have a EBS volume attached into the EC2 instances, and also we have database as well. So if any unencrypted storage, that will be a big security concern actually. So that will come under pitfalls. And also over permissive of IAM roles. So by giving the IAM, by assigning the IAM roles to the particular user, that we should conscious about the roles actually. Why? Because if we give admin our full access, if they did anything wrong, there will be a misconception will be very high, and like impact will be very high, right? So we should restrict those IAM rules as well. And non-compliant instance types, which means like recently AWS support announces like if anyone using IMD version 1 in any EC2 instance, that is a big misconfiguration into the security perspective. So they ask the customers to upgrade into the IMD version 2. So that one also the pitfalls of complaints. And next one is like what is policy as a code. So policy as a code, this very important topic here. So these are methodology that involves writing policy and regulation in the form of code, which is closely related to infrastructure code. And see, for example, depending on the tools you select, like instead of manually implementing or enforcing this policy, we can expose them into code using JSON or YAML format or specialized domain-specific languages. Why? Because in our scenario, like we are going to use open policy agent as a policy scope. So there we are going to use Rego. Rego is like a declarative language. So we are going to use that language to enforce the policies actually. So the benefit of implementing the policy score are as follows: like consistency, which is very important, and scalability. Scalability, which means like we can enforce a policy without manual intervention, and traceability, documentation, and auditing as well, and also cooperation, which means like if we have multiple teams in our organization, we can collaborate and reuse that policy to enforce the policies. That is a big benefit to implement these policies actually. And next, what is OPA? Open Policy Agent is like actually this open source policy engine, so we don't need to get it the interface itself. So we can use open source policy engine that allows you to define, manage, and enforce policies as I told across different part of stack. And the major benefit of selecting open policy agent is like we can enforce the policy and framework for policy across the cloud stack, including cloud infrastructure, Kubernetes, containers, APIs, service mesh like Istio, and CI/CD like Terraform Action or GitHub Action or Jenkins. So here also we can enforce the policies. Enforce the policies in the OPA to create a pipeline actually in CI/CD using that. So it will be automatically enforce the policies whatever we are going to create using the Terraform code. So that is a big advantage of the open policy agent. And also the finally like this is a general purpose policy engine which is evaluates JSON data, which means like so when we are going to apply a Terraform apply or Terraform plan, we know that we should generate a code as a JSON using the command promote. So in that JSON command only, we are only using the JSON TF plan command, JSON command only. We are going to enforce the policy using the Rego actually. So the JSON data against user different policies, it will be Rego. Rego is a declared language. I'm going to explain a bit more about Rego as well. So to apply the enforce the policies to the Rego and conference, the JSON data is important thing actually. So before we Terraform plan and apply, we should change the code into the JSON data. Then we can enforce the policies. So without changing the JSON data, we are unable to enforce the policies using the open policy agent. And these are like how does open policy work? Like we have a policy input and query, which means like the policy's default is the repo. So once we define a policy into the using the repo, it will get input, and then it will run as a query. So input is run as a query, and then forward to the open policy agent evaluator. Then finally it will give the result actually. So this is the open policy architecture to work on behind the scene actually. So policy is default. So after the policy, we enforce. It will get the input, and input is running as a query. Then send it to the open policy agent evaluator. Then finally, we'll get a result like it is. See, for example, if I'm going to apply S3 bucket, so if anything misconfigured over there, it will be so like for example, two result, one error or one warning or one success. This the result is showing. So, based on the result, we can identify what we misconfigured into the Terraform code. After if we face any error, if we see any error after the open policy agent enforce, then we should fix that error into the Terraform code. Then we should execute again open policy agent. If no error, then only we are going to apply a Terraform apply. So that is like full flex of like without security misconfiguration, we are able to create a resource in AWS or any other clouds actually. And the next is like what is Rego? Rego I talked about in my previous slide. Like this is like a declarative language actually. So in open policy, particularly in open policy agent, we are going to use Rego. They have defined as a Rego, that is a declarative language, and also Rego provides like a rich set of built-in functions. So which means like we can use to manipulate data and perform operations such as filtering, aggregation, and transformation as well. So I will show you the Rego, some sample Rego policy in on the slide as well. So understanding Rego and Terraform integration. So here is like as I told, like Rego is enabled expressive, and also we can reuse that enforce policy. That is like a modular policies as well. Seems like module, it means like we can able to reusable. So using the same policy. In the similar changes, we can able to apply not only AWS or Azure, we can apply into other clouds as well. And also a basic OPA policy can enforce Terraform versioning because so like a Terraform we should install Terraform versions like version 1.5 or greater than equal to version we should be installed because after Terraform 1.5 only they have implemented OPA policy. So we can import Terraform versioning, tagging. As I told, like tagging is very mandatory field in all the resources, and encryption, that is also the very big challenge in security perspective. And allowed region seems like allowed region and instance types as well. So allowed regions like see, for example, I'm using the EU West 1 region in to create my all the resources in AWS, right? So by default I should select EU West 1. So when I create resources using the Terraform, so there also I should mention about the same version. So if I mention in the different version, different region, so what will happen? Like it will be get into the that what I mentioned into the Terraform code, right? So so there it will be resource will be created. So which is like, but I'm using the different region, right? So that is misconfiguration of region. So that should be enforced into the OPA policy. That is a best idea actually, right? Because we are always conscious about the region. So which region we are using to create resources, that region only we are going to use it in Terraform code as well, and instance types as well. And also, like as I told, like OPA evaluates JSON plan before Terraform apply, right? Because the OPA policy enforcing is using the Terraform JSON plan format. So before we apply a plan, we should create a JSON plan format. Then the context will get the policy defined into Reco, pull it from the JSON plan format actually. So this is the example Reco policy, which is like a region restriction. So because here I have used package Terraform, sorry, package Terraform.rgc, this is the package actually, and default allow should be false actually, and here allow I given region actually. Region I gave here UK South, which means like all the resources which I'm going to get using the Terraform code, it is going to be created into the UK South region. So if I so for example in this is the reco policy. So but in main.tf, which means Terraform code, which I written where I have written like if I mention different regions like EU West one, which means I will get a error when I run when I enforce the policies using the OPA. Like region is misconfigured, we should change it like that. I can see. So then I should change I change the same region into a Terraform main.tf as well. So this is the reco policy and how I'm going to integrate with Terraform, and how the OP and Terraform work together. So this is the command, right? Command to generate a Terraform plan into TF plan format. This is the command Terraform plan dash out equal to TF plan, which means like whatever I mentioned to create a resource into main.tf, I can able to see into TF plan. So after that, Terraform show JSON JSON TF plan.json, which means like this is the method to enforce my policies using the conf test. And finally, open policy agent will evaluate into a JSON format and returns it to a success or failure. If it is any error, I should check the code, and then I should change and meet into the meet into the open policy agent policies, which means like Terraform code I'm writing into create a resource, for example S3 bucket. Then once I return the proper Terraform code, then I'm going to run a Terraform init after initializing the plugins. Once the plugins are initialized, then I'm going to run the Terraform plan. After that, after Terraform plan, I'm going to uh, um, changes like JSON format. Once JSON format is confirmed, then Open Policy Agent will evaluate JSON format, and then if there is no error, if any error, I should fix it. Then I'm going to apply it. So this is the integration between the Open Policy Agent and Terraform work together. So let's get into the demo. I'm going to show you the live demo. So this is the this is the main.tf Terraform code I have written. So I'm using here the version and HashiCorp AWS, because I'm going to create resource into the AWS cloud. Then I'm going to use US East 1 region. So here, for example, I'm going to create a S3 bucket. So this is the bucket name. So here I given public read, purposefully I given public read because we don't give public read for S3 buckets. That should be private. So purposefully I given public read. Then this is a tag. As I mentioned, tag is mandatory. Right? So the name, demo bucket, and environment this dev. So this is the Terraform code to create a S3 bucket, and this is like policy. So S3.reco. This is the reco policy which I'm mentioning about the policy to enforce it. So here I'm writing first package is main, which is main.tf, and then deny if an S3 bucket is public. yeah, that is important, right? So if the S3 bucket is public, that should be denied, which means it will be enforce the policy and provide us error. So deny contains message if, and then I given here the type is like S3 bucket, and then public read. If it is in public read, the error should be thrown. So after that, the bucket cannot be public. This is the error message will be printed out, and deny environment tag is missing. So if environment tag is missing also, it will be throw error like you should mention about tag something else. So here I mentioned S3 bucket, environment tags, and the same thing. So but here I mentioned tag. Because of this, I don't get error for tags. I will get only error for ACL, which is public read. And confidence atomer. This is the confidence to test the test and enforce the policies. So policy path is like a policy. In the under the policy, I given S3.rego. So I'm going to so our main.tf code is ready, and S3 rego policy is ready, and confidence atomer also ready. So don't worry, like all these. Steps and prerequisites are there in my GitHub, so you can tag your hands. So these are the prerequisites or to run this OPA and Terraform smoothly. So first one is like Terraform should be version 1.1.1.5 or greater than 1.5, equal to 1.5, and config should be installed. If it is in Mac, you should use this command pu install config. If it is in Windows, you should use this go install GitHub own policy conf test latest. So before that, you should install go. If you are not installed go into your laptop or desktop. So once you install go, you are good to install conf test using this GitHub link using this GitHub link actually. And also AWS CLI should be configured. These are the prerequisites. So all these three is met, then you are good to enforce the policies for your Terraform code. So first we are going to initialize, and then so I'm going to initialize down first. So now initializing will take some time. So once you initialize, the backend will be showing here like Terraform and what are the providers is going to be installed. So this kind of information you can see it here, yeah, under the Terraform folder. So it's successfully initialized now. Then the next command is like Terraform plan out TF plan. So I'm going to run this command. So this will take some time. Yeah, it's running now. So I could see the plan.tf plan is created here. Then the next command is like Terraform. So this is the command, like I will also explain it there. Yeah, this is the command to already we have plan.tf plan right here, right? So we are going to convert as a plan.json. So this is the format to help us to enforce the policies using the conf test and record policy. So I'm going to create a plan.json using this command. Yeah, now the plan.json is created. So here we could see a format the version Terraform, which version are Terraform we are using, like a 1.11.4. This we are good actually. Why? Because the prerequisite is like Terraform should meet 1.5. So we are greater than of 1.5, and these are planned values and what are the issues is going to be created. So this kind of stuff we could see it here in JSON format. and what is the bucket name and what will be provided into the main data if you could see it here. Life cycle policy and everything you can see it here. So whatever I mentioned into the main data here. So now the time to test our enforce the policy. So this is the command to enforce the policy. Conf test plan.json. So whatever they are in the plan.json, uh, whatever they are into the plan.json, it will be checked the security configuration. See if anything error or any success or warning message you could see after running this command. So I could see here two tests. One is passed and one is failure because we given here public read right. Also we mentioned here if anything public read the policy should be denied. So because of this it is denying. So then we should change this from public read to private. So I changed it here private. Now I'm going to save it. Now again, I'm going to run these commands actually. First, I'm going to use the from plan or plan tf plan. Okay, and the next command is like we should change the tf plan into plan.json. Yeah. Now I'm going to run conf test. So now you could see two test, two passed. Why? Because before it was public. Now I change it to private. So there is no security misconfiguration right now. So we are good to apply this. Actually, apply this resource to create actually. So data from plan apply hyphen appro hyphen apply. This is the command to apply the um, resource to be created actually. So if all passed, we are good to go ahead and create the resources into the AWS cloud. So it is going to be add this, going to be create the bucket and with these specifications. So it is completed now. So now I'm going to check it here whether the bucket is created or not. S3. So here you could see this is the bucket name I given. I mentioned into the Terraform code. So it was created right now. And also I'm going to check the properties. Under the properties, I could see under the properties you could see all the settings which we expected like tags we as we mentioned like environment dev and name is demo bucket, which is good actually. And the next setting is like permission. So under the permission, we could see block all public access on, which means like we are good actually. So this packet is in private purpose. So these are so we are good actually. So it is working as expected. So this is the sample policy to create S3 bucket. So for similar to this, we can whatever resources we are going to create, you can mention about the repo policy and then enforce the policies. So this is the demo actually today. And next one is like I'm going to show you like use cases. Let me transfer screen. So next is like use cases. It's like cloud security and compliance, which I choose right now, and enforcing data access control policies. Like we have see for example, if you are working into data engineering field or data science field, there we have a lot of control policies are there, right? So if you want to enforce those data related policies, you can use open policy as an open policy agent dedicatedly, and also the authorization of Kubernetes or Docker containers or service mesh like HTO or something HTO or Linkerd or something else. So for authorization also you can use this open policy agent effectively. And the next one is like this the key takeaways and learnings. So we discuss about zip lib comments, which is like before before producing the infrastructure, we should detect and prevent the misconfiguration and Terraform plus OPA, which means like Terraform with or integrated with the Open Policy Agent, analyzes the plans without blocking the ASD workflow. And also we can automate this via the CI/CD. So CI/CD we have like GitHub Actions, Jenkins, or GitLab CI, right? So using that CI, if we create a pipeline into that. See, for example, if you are using Jenkins, so in the Jenkins, if you set up the pipeline to run to enforce these policies using the open policy agent, if you set up pipeline, that is enough. So always when we run the Terraform, when we create a Terraform code, and when we run a build into the Jenkins, it will always test the OP, or always enforce the policies in the open policy agent and provide the output actually. And this is the modular policy as well. As I told, like record rules can scale across teams, environments, and resource type as well. And these are the learning outcomes. So like we should understand how OPA evaluates Terraform plans for compliance, and learn to write and debug Rego policies for common IS use cases. So for here example I shown like the S3 packet only, right? So we have a lot of policies we have a lot of resources into the all the clouds. So for all those resources, you can create Rego policies and debug it if it is working perfectly or not. If any error in the policies, we can debug the code actually. And also, we are gain hands-on experience integrating confidence in CI/CD pipelines as well. And also, we can recognize the importance of the policy versioning and cooperation in large-scale DevOps teams. Using these the key takeaways and learning. Thank you. Hope you all enjoy my session and learn something about open policy agent and Terraform. So these are the resources I took from the URL, or these open policy agent documents. And this is the Terraform plus open policy agent guide, and this is my GitHub actually. You can test my repository, and you can check my repository and test it out from your end actually. So this is my LinkedIn profile, and this is my GitHub. You can scan the QR code and connect with me. So if any doubt or any questions or any help you needed, you can DM me directly. Thank you.
All right. So thank you, Selvam. So it is a great session with Terraform and OPA demo. So you covered everything on what is OPA and how to write a OPA policy, and you also showed us a very good demo of like how OPA policy can be useful for doing the infrastructure security checks, right? So basically, like OPA, as we all know, like helps to do infrastructure creation uh, right in the right way, right? Using the Rego policy, and combined with Terraform and OPA, they can do magic, right? So as both of them, like both of these tools allow organizations to be compliant with all the security policies, be it compliance policies or Kubernetes container security rules or cloud config rules, right? So that's a very useful session, Seldom. And as an announcement, remember we will be sharing all these talks on YouTube in coming weeks. So if you are just tuning in for this HashiTalks 2025 India, you can catch up those sessions later. And up next is a session from Neil Shah. Neil Shah is going to talk about observability-driven infrastructure with Terraform and OpenTelemetry. And just to introduce about Neil, Neil is a DevOps engineer with a great passion for building communities around DevOps and cloud. He is organizer for different cloud and the CNCF group for Gandhinagar, and he is also a HashiCorp user group lead for Gandhinagar. He loves open source, and he has mentored 15 plus hackathons, and have given talks across globe in various conferences, right? And yeah, let's have what is Neil having us to for us today, right?
Hi everyone. Welcome to another session of HashiTalk India 2025. So today we have amazing topic, that is observability-driven infrastructure with Terraform and OpenTelemetry. Hi, this is Neil Shah, a DevOps community guy working as a developer advocate at Middleware. And I'm also one of the HashiCorp ambassador from India, and also the co-organizer of HashiCorp user group Gandhinagar, Google Cloud Gandhinagar, and CNC. Have mentored more than 50 plus hackathons and have given talks in 10 plus conferences, including KubeCon, PlatformCon, Linux Fest, KCDs, and previous HashiCon. So let's see. What we have today is the problem blind spots in ISE. So infrastructure as code had made a lot of deployments reproducible, scalable, but it's often like a black box. Consider an example where you imagine a Terraform apply that changes IAM policies a week later. An S3 bucket becomes inaccessible. So you have no trace linking the change to the issue. That will be causing a lot of troubleshooting then. So in multi-cloud environments such as AWS, GCP, Azure, each has different APIs and drift behavior, so leading to invisible failures. And traditional monitoring tools only show the services that is down, but we also need observability with infrastructure changes. So it is very much important to cover this topic today to discuss this because a lot of people are already using Terraform, and if we implement observability with that, then it can help you a lot. Next comes the evaluation of observability. All the people who have joined here always know observability. So let's look at observability has evolved. Matrix-based monitoring. So it gave visibility into CPU, memory, latency. Next comes tracing-based monitoring. It gives you user flow, help track user. And then came unified observability. Unified observability is infra plus application plus CI/CD, everything with OpenTelemetry. Full lifecycle visibility of how we see. So instead of just knowing your API was slow, you can now trace that slowdown to a Terraform change that resized your database node. So you have full access to all the things that you have today. Next comes the Terraform plus OpenTelemetry. If you know OpenTelemetry, this is the one of the biggest project contributed in the CNCO landscape. And together, Terraform and OpenTelemetry makes ISC observability, that is infrastructure as core observability, and makes our life very much easier. Think of Terraform not just as apply and forget, but as a traceable workflow. Each Terraform plan or apply emits span, start, resource creation, maybe completion. Metrics like plan duration, apply success rate, and resource errors get exported. And logs become structured even with trace IDs. Example, every Terraform apply emits a trace in OpenTelemetry, visible in some dashboards. You can literally see which module or provider and the resources are changed, just like an application request trace. So it becomes very much flexible for us to see each and everything, and that makes our life pretty much easier. Terraform becomes much more accessible and traceable because each and every of plan and apply will be traceable. Next comes instrumenting Terraform executions. So to collect this data, we instrument Terraform execution. We can wrap Terraform commands using the OTel CLI or integrate with SDK. So here, with the Terraform apply, we need to also give some more execution commands. So if a Kubernetes cluster creation takes 9 minutes, it's shown as a long span in your trace view. If you know trace, then trace gives you the whole user journey of each and every of your request. It has the one parent ID, and which with that, it has associated with all the child IDs, the service IDs. So the whole user journey, if you go, you can see that, and you can find out at what place, at what time, if it took much time and it took lesser time. So you can integrate GitHub Actions or Jenkins or Terraform to track your performance reliability. Next, we will see how we can propagate the trace. So the real power is in the correlation. When we propagate the same trace ID across all your CI/CD pipelines, every infrastructure change is linked and its downstream effects. For example, a developer merge is a PR that triggers Terraform apply. The same trace ID will appear in your Terraform execution traces, the OpenTelemetry backend, and if an outage occurs 10 minutes later, you can instantly trace it to the exact Terraform commit and author responsible. So it will be a no blame game. You will have proper visibility of each and everything. Next comes drift detection and auditing. So Terraform drift, if you know that, you can also always detect all the drift. Drift is basically the change made in your infrastructure, comparing with what you wanted and what actually changed. So one major issue with IS is drift. When the actual state diverges from the declared state, we can detect this by comparing Terraform state files and exporting the drift matrices of OpenTelemetry. So you have two matrices, two different components to compare. So you know. So through OpenTelemetry, this is also one of the good feature. You can detect drift of your infrastructure. If Terraform says a GK cluster has 3 nodes, but the GCP shows 4, we have made a drift detector one metric. We can then visualize the drift over time, audit which modules change more frequently, and even alert when unauthorized change occurs. Next, we will go with unified observability dashboards. So merge all infra matrices, traces, and logs into a single pane. We will see now. Imagine having all data in a single dashboard will help you a lot. Example dashboard, use CPU spikes annotated with Terraform apply events. Another could be drift rate, depends per environment. We can figure out a lot of graphs, a lot of batteries, a lot of charts at a single place, and it will be very much helpful for us. Now, scaling ISE observability, how to scale that? As infrastructure goes, so does OpenTelemetry volume. So where the OpenTelemetry collector help is the backbone for scalable observability. Collector receive traces from multiple Terraform pipelines. The processor processes and the enriched data, and the exporter sends data to let's any OpenTelemetry platform. Maybe we can use OpenSearch here, Tempo, and Prometheus for metrics. This architecture ensures that we can handle thousands of Terraform operations per day without losing signal fire reliability. So, what are the key benefits of integrating OpenTelemetry with Terraform? So, it helps us with faster root cause analysis. Let's say if a deployment breaks something, you can pinpoint the change instantly. Next is auditability. Every plan and apply becomes an auditable, traceable event. Next is reliability. Reliability helps you to identify drift detection, ensures every change in infra is consistent, and confidence. Team gains trust in each and every change you apply. For instance, a financial services company used this model and reduced the mean time to detect infrastructure issues by 40%. This can be very much helpful. So the end-to-end flow, let's recap the end-to-end flow, how it occurs. Is a developer runs Terraform apply, OpenLibrary captures the execution spans and matrices, the collector routes the telemetry to any platform, and if an incident triggers an alert, the trace link directly apply to that event. This will show how it applied and what changed and which service was affected. So if Terraform, let's say we have an example called as if Terraform updated a load balancer target group that caused 502 error, you will be able to see both events in same trace because you know from which role it has affected. So what are the key takeaways? Key message is observability isn't just for applications. Extend it to infrastructure and it will help a lot. So we are instrumenting Terraform with OpenTelemetry, reconnecting, planning, deployment, and runtime feedback. Example, imagine if you have applied Terraform apply as not just an infrastructure change, but as mentioned, measured, and explainable event in your observability platform. So you get a lot of understanding of your system and also the Terraform you apply, the infrastructure you created. Yeah, thank you so much for listening to this. Hope it helped you. It gave some of the new insights to you, and it can bring you some good value to you. See you in next history talks.
Yeah, so that was a great session on open telemetry from Neil Shah. So basically, so why we need to do open telemetry, right? So Neil's session has covered the major part of it, like no, because whenever we are creating infrastructure, we need to have a traceability of like no what it does, like who creates an infrastructure, and those kind of aspects needs to be covered. And for that, doing a traceability of like what happens with the infrastructure creation is very important, right? Because that is the one that is going to talk about like who does what and what infrastructure is having as a traceability, right, from end to end creation, right? So his session covered like doing instrumentation of how to do instrumentation of Terraform executions, and he covered tracing context propagation, and how to do a drift detection by doing the audits. So his talks covers all of it, right? And generally, if you are talking about HashiCorp tools and the technology stacks, right? So as I mentioned earlier, like there are two different ideas comes in wherein infrastructure lifecycle management and security lifecycle management. And the infrastructure lifecycle management covers everything with respect to creating application infrastructure in cloud or on-prem or multi-cloud, right? And in that aspect, like all the tool sets comes in is like Waypoint, Terraform, and all other tool sets, right? Similarly, when we are creating infrastructure, we also need to have a stronger security aspect of it, so that whatever infrastructure we are creating will be very much intact with all the security aspect, right? Because nowadays it's very important to protect the applications from all the vulnerabilities and security attacks, right? That is when HashiCorp has the tool sets like Vault and Boundary for accessing, right? And for API management, we also have tool like Console. And so that's about the overall aspect of HashiCorp toolset. From my experience, if I have to talk about like how we use HashiCorp technology stacks, right? So basically, like when it comes to DevOps process automation, infrastructure creation is one of the key aspect of it, right? And HashiCorp as a company has a leading tool sets that helps to do infrastructure automation, right? So whenever there is an application is being developed, it is also important to create an automation for how this application is going to be deployed in infrastructure, right? In that aspect, we have to do a cloud infrastructure architecture whenever that application is being developed, and that is also part of the overall. Teams can do a end-to-end automation by using infrastructure automation by integrating HashiCorp tools, right? So in the CI/CD pipeline, when you are creating, so we will be doing the build and then creating a containerization and doing the registry storage of the particular application, and then we will be creating an infrastructure automation using Terraform kind of tools, apply security rules, and then deploy the code, right? So that is how it should be. And in that aspect, let's move on to the next talk for today. So next talk, it is going to be from Paras ma'am again. He is going to, the talk is going to be covering about breaking down cloud barriers, standardizing deployment across the diverse environment. And if I have to introduce Paras, so Paras has been an active speaker, sharing his technical expertise across Google Tech conferences, and he is also a Linux Foundation open source summits in various countries. Paras is a highly skilled backend developer with a passion for information retrieval and the knack of translating complex technical concepts. So now let's hear from Paras on his talk, what he is going to talk about breaking down the cloud barriers. Yes, Paras.
Hello everyone, and thank you for joining in. I hope you're having an amazing experience joining in on the HashiTalks India, learning across different sessions, different interesting technologies, and what's happening on the HashiTalk technologies, working across different cloud providers, automating different stuff. As part of that sessions, I hereby Paras will be speaking or talking about a topic which is at the crux of different cloud service providers. So we'll be working or we'll be discussing about how we can break down different cloud barriers, and that can be achieved by standardizing the deployments across diverse environments. So with that in mind, let's move forward. So as the name suggests, we'll be looking forward towards how we can standardize the deployments towards different cloud service providers. And with the intent, with this as an intent, we have this agenda lined up. The agenda is basically, we'll start with the problem statement. Why do we need these standardizations? How it helps, how it benefits us moving forward. Second is, what's the HashiCorp's approach towards it? What is the common language they are working towards? How they are helping us or giving us a step towards standardizing this. The next is having a strong cloud foundation, irrespective of which cloud service provider we are. If we are looking forward to build a very robust, reliable infrastructure, then we should have a very strong cloud foundations on which our workload can rely on. After that, we'll see how a practical hybrid pipeline works, followed by its impact on real-world use cases. Then we'll briefly cover about a reference architecture in the next steps, and going forward, the road ahead that we have for us. Starting with the problem. The problem is like the multi-cloud chaos. You can see, like, as an enterprise or as any company who is looking towards running their workloads across multiple cloud providers, be it any cloud provider, the movement towards cloud is great, but one of the thing that as an engineer, as a dev team, see as a challenge is how to work towards different cloud providers, or how to code or how to speak to these cloud providers in terms of technology to have a uniformity across in some way or the other, because every cloud provider has their own language, their own set of frameworks, CLI tools, which is being used to deploy the workloads. With that in mind, each have their own unique models, the IAM systems, the APIs to which we talk towards. Eventually, what this does is it results into different deployment strategies, different policies, additional operational overhead when things are being deployed onto the cloud, onto the different cloud, eventually leading to teams spending more time in managing these differences than delivering the core the result towards the core problem statement that they had. Or basically, instead of focusing on their main problem statement, some part of the attentions gets diverted into managing the ecosystem that exists in the multi-cloud. So with that in mind, it's like if someone wants to deploy a certain workload in cloud A and the same has to be deployed in cloud B and C, then this is where they have to understand the entire language that that specific cloud talks about, or they can also speak about using a standard language. And that's the standard language that we want to speak on here and dive into it. So why do we need this standardization? So this was the solutions we want to address. But even before we go to the solution, why do we need that? The reason is like without such standardization, the automation, the automated pipelines that are the core of deploying the workloads, the core of deploying the infrastructure, the chances of they breaking in increases exponentially. So every time there is such issue, someone or the other has to pitch in, do some manual adjustments, fix any issues, and then redeploy the infrastructure, followed by redeploying the workload. That's not only it. This right after you have deployed, then you will again have to work towards the security and compliance, because each environment has different security and compliance policies, and then that would require a similar effort that was required in the previous stage while setting up the infrastructure. So think of a way where you first deployed the infrastructure across different clouds, and then you have to set up the security and compliances across these different clouds, across different environments, and then work towards it, fixing those issues. However, while this is a cumbersome approach, but there could be a better approach have we had a standardized approach. And that is something like where developer wants a predictable way to deploy, a standard way to deploy, regardless of where it is being deployed or what is the underlying platform where this infrastructure will be deployed. And this is what we eventually are looking after. So this helps us to develop a unified pattern, a reusable modules, and a policy driven workflows where the same pattern, the same reusable modules can be deployed across different clouds, the same architecture can be recreated elsewhere. It's easier for the developer to reuse code more than it would have been if there is a unstandard approach. So this is where this iterative cycle of using the code, iterative cycle of building a seamless automation comes in picture and helps us to provide a very seamless experience for the developer to give a great experience to their respective customer. So what the HashiCorp's approach is, there are many other tools which can be leveraged. We've just highlighted few of them. To start with is the Terraform. So infrastructure as code is like like we used to write any application using programming language. Similarly, we can create infrastructure using code, and that code is Terraform. So it provides like a declarative model. So it uses HashiCorp language to define your configuration, your infrastructure in form of a language, in form of your code, in form of your script, which sets aside like you can then reuse the same script, same part of code across multiple environments in different like across multiple environment in different use cases to create that same stable, reliable, or thoroughly tested infrastructure. Let me give you an example. Let's say you have a certain setup or an architecture and you want to create the same infrastructure in dev environment, in test environment, and in the prod environment. So instead of writing it thrice or going through the cumbersome approach of using console or some CLIs, you can actually write this code like we do in the release, in the usual application release process, where you write the code in dev, you test it in the test environment, you test it again in the non-prod environment, and then eventually release it to the prod. And this is basically like a gradual or incremental approach of reusing the code instead of rewriting it again from the scratch. So this is how like Terraform helps you to create or create your infrastructure using the programming language. Moving forward, similar to Terraform, there are other tools. So we will just quickly cover about them. That is Packer. So Packer is like another automation tool which helps you to create your custom or OS images, where if you have like, let's say if you want to automate certain images, images like it could be any operating system, and you want to bundle it them, which comes with some pre-installed binaries or some customizations that you want, and you want them to be integrated. Like for example, if you are deploying a certain virtual machine and this virtual machine should have a customized OS, so you could build such customized OS using Packer, deploy the infrastructure using Terraform, and configure the Terraform deployment that it uses the OS which is created by Packer. So this is how like it could help you do that. And on the same lines, we have Waypoint and Console, where Waypoint helps you to the consistent application deployments across clouds, and Console helps you in providing a unified service networking and discovery. So like these are like the entire different suite of products when bundled together give you a universal translation layer for the cloud infrastructure, which is like pretty platform agnostic, and gives you enough flexibility to move across different clouds without changing anything towards your pipeline or whatever the whole ecosystem that you have built. So you can continue to play around with the endpoints, like which cloud you want to point to, which workload you want to deploy, but overall the approach, the seamless approach of deploying different workloads, it remains as is. Now coming to the strong cloud foundations. So while you have, this is like I'll say one of the most important slide, I will say, irrespective of which cloud service provider you use, which workloads you are deploying, this is like a bare minimum if you are going ahead or setting up of cloud, one should have in mind. So starting with like a zero trust architecture, network segmentation in form of VPC networking, firewall rules, security groups, a key emphasis on an IAM policy, ensuring that encryption of your data is enabled whether the data is in flight or at rest, and the high bandwidth connectivity. So what this does is it ensures that whenever you are deploying the workload or whenever you're getting started with your cloud journey, you have security first approach from the very beginning. Whether you are building with a zero trust architecture, whether you are ensuring that your network has been segmented thoroughly, where your dev workload, your test workloads, your prod or non-prod workloads are thoroughly segmented into different clouds. The VPCs, the firewall rules are pretty restricted enough that ensures the security is not compromised. The IAM policy rightly restricts the access of rightly restricts the access and give only the sufficient or the necessary permissions required for the dev engineers to work on, instead of giving a very elevated set of permissions. And then the encryptions, which is like a very, very important part, where we ensure that we have done the necessary configuration to ensure that the data, whether it's in flight, that is while being transferred, or at rest, whether it's in the form of some data store, is always encrypted. So this is a very, very, I'll say, important part of building the infrastructure and deploying applications, workloads in the cloud, where we follow the security first approach right from the beginning and move towards that. Now, there are many hybrid pipeline. One of them that I have taken as an example is where we have certain workloads on on-premise or maybe on the cloud, plus GCP and the HashiCorp. So what we're trying to say it in here is we have a provisioning with Terraform where we do a single unified Terraform configuration to define our entire network from VPC to firewall, and we could recreate this infrastructure using this repeatable piece of code. So irrespective of which Terraform, which cloud provider you are using, any Terraform that you write, that's the essence of it, that it is a reusable code. It helps you to incrementally expand or add more features or more configure more values into your infrastructure without hampering any of your existing infrastructure. So let's say if you have created one VPC, now you want to add few more subnets within that VPC, you can incrementally add it rather than you will have to set up everything from scratch. So this is where the Terraform helps you to incrementally create your infrastructure, to help you work towards your infrastructure, to help you cater to your future workload needs and work towards that. Second one is CI/CD approach, where this is like how you deploy this workload, how you maintain this entire end-to-end pipeline plays a crucial role. So what do we mean by this is, like, let's say you have now Terraform code written. So how are we supposed to deploy it? Are we expect the engineers to deploy it from their machine? To which we will say no. Yes, you can do that while testing, while developing. However, the ideal way to deploy it is you push your code into some source code repository. It could be GitHub, GitLab, or anything else. Let a reviewer review the code. Once the code gets merged, the merged codes then gets executed via a pipeline or via tool like Jenkins, Travis, or any other ecosystem that you already are familiar with or your team is familiar with. And that then triggers the deployment of workload towards that specific cloud. So what it does is it's like an automated testing and deployment that happens. You have all the necessary tests developed which are being tested before the code is merged into the main source code repository. Once it is being thoroughly tested, a reviewer reviews the code. Once the reviewer is done, it again goes through some unit and integration test pipeline. Once everything passed, it gets merged, and once code is merged successfully, it then triggers a job which eventually ensures this deployment of source code is now reflected as infrastructure that we have been running in our respective cloud service providers. So this is where the CI/CD approach helps a lot. And the last one, which is like part of a component of CI/CD, is automated testing, which is like very crucial because the automated testing is like an pretty important part where we don't expect every single user to be aware of every specific scenarios. So as much as we can, as much as code coverage we can, as much as scenario coverage we can, we should automate the testing. There are several tools. There are some inbuilt Terraform test functionalities which is available. You can use that. You can use several other open source libraries, or maybe identify what are the things that you could do. So you can just to highlight, you could use Terraform inbuilt testing facility. You could also use an open source library that helps you to automate unit and integration testing. So this will help you to save your time while during the development, during the testing, during the production rollout, and will give more time to your team to brainstorm or to work toward actual problem statements. So these three will be the minimum to ensure a seamless experience. And with that in mind, once you followed, like the real world impact is like global enterprise can deploy their workloads across different cloud providers. So for example, I mentioned few of them, but it could be any cloud providers, because nowadays Terraform is being supported pretty much widely across many cloud providers. There are standardized Terraform modules and the folder structure for libraries like night networking, IAM, workloads, and you may even find quite a well references for the same in the respective cloud providers directories. So Waypoint is one way where you can do the deployment, which is like a one command deploy. And the outcome that we would have by now realized is that we see a huge reduction in the environment setup time, where it's like a one-time effort, which then can be reused by your team. We see zero drift across environments because it's basically one standardized code which is being deployed or which is being redeployed across different environments with different configurations. And it's very easier to audit and reproduce, because like every configuration, every parameters is in the form of code. It is very easy for a reviewer, for an engineer, for a security audit teams to go through that to see if there is anything that needs a thorough check or that needs further improvement. Here is a brief example of one of the reference architecture. I'll not go in detail about that, but this is like a very complicated architecture where we have certain workloads running on-prem. This on-prem, just to give a context, this is a reference architecture I have created using the Google Cloud resources, where we have Cloud Interconnect, Cloud VPN connecting to NCC, which is like Network Connectivity Center. So what this helps us to achieve is, it helps us to achieve from other cloud providers or from on-prem to Google Cloud Network. Now you could leverage Google Vertex AI services, as well as you can also leverage any other cloud provider services, because now you have established the connectivity using cross-cloud interconnect, cloud VPN using NCC. So think it of as a way of an entire ecosystem where now your workloads running on-prem, workloads running in other cloud providers can connect with GCP, with Google Cloud services. They can interact with it, they can perform the CRUD operations, they can leverage Google Cloud Vertex AI services, and they can cater to the application workloads as you desire to. So this is at a high level. You can expand on it, you can go through that, and in case you have any questions, feel free to drop me a message. And how do you achieve that? We have automated the same using the Terraform. So you can see we have split this setup into two halves. One half is where you set up your secure hybrid network connectivity across on-prem or other cloud providers to GCP using NCC hybrid spoke. So that's the step one. And the step two is where you want to use Vertex AI vector search over the network you have set up in step one. So if you scan through this QR code or you go through this URL, you will find out all the necessary instructions, and all these instructions are using Terraform, where this entire setup has already been automated, thoroughly tested, and any user can just go ahead and try and get their hands experience with the Terraform. So you can even replace step two with elsewhere. Let's say if you don't want to use Vertex AI straight away, you want maybe Cloud SQL or AlloyDB to be used along with, you can do step one. Step two, you can set up Cloud SQL. Step three, then you can set up the Vertex AI vector search. So this is how like you can incrementally search, and like I'm just sharing this code. This is how easier it becomes for you and your team to work on the same code, to work towards it, to share, to collaborate. Like it's an open source repository, so feel free to collaborate, add your comments, add your suggestions, raise issues, and even do some contributions if you require. So the road ahead, so I'd like to conclude that the road ahead is basically standardization enables innovations. It helps you save a lot of time. It free your engineers to innovate new solutions for the problem statements, rather than continue to focus or invest a lot of their time into the configurations, into the setting up of the existing infrastructure, and vice versa. So you can basically like invest more time on your innovation, on solving your problem statement, rather than doing the manual stuff. And that's because you've automated the workload deployment. Second, the cross-cloud standardizations help you in a hybrid and a AI workload journey. So like the previous example just that I have taken, it's like a true hybrid approach and a AI workload thrive, where you can like standardizing this, it has enabled you to actually try out different cloud service provider, whether it's cloud service provider, whether your workloads is in the on-prem, you can actually bundle the resources together. You can bundle your problems in different products and services together to solve your problem statements. So this is where it enables you to do a lot more than we could think while doing it manually. The future is like the more we see IAC integration policy as code and intent driven deployments, because it is a step towards automation, it's a step towards cloud agnostic approach, and it's not only help us giving us more time to address our problem statement, it also gives us more liberty to try out different clouds and different services. So, as a closing remark, I'll say breaking barriers isn't about just choosing one cloud. It's about making every cloud feel like home and trying out or choosing what's best for the problem statement and what's best for the business. With that in mind, I'll say thank you. I hope this session was of interest to you and looking forward for your queries. Thank you.
All right. Thank you, Paras. So it was a very insightful talk. So it is very important to consider multi-cloud strategy as part of cloud adoption nowadays. And the Paras session has covered the major aspects of it and how to do. And we also recently seen a major outage from one of the major cloud provider. That incident highlights the need for organizations to consider the multi-cloud strategy as part of their cloud adoption, right? So with that, like no, I would just like to call out an announcement. We will be sharing these talks on YouTube in coming weeks, and if you are just tuning in, you can catch up those sessions later on YouTube, right? With that, let's move on to next speaker, Nikita. She is going to talk about infrastructure as code meets prompt engineering and AI-powered Terraform workflows, right? Introducing Nikita. Nikita is a seasoned cloud professional with over 8 years of experience. With 5 years of deep expertise in Terraform, Nikita has developed standardized reusable modules. And yeah, let's hear from Nikita, what she's having for us today.
Thank you, Sarah. Once again, we are here on HashiTalk India. Hello, am I audible?
Yes, Nikita, you are audible. Please go ahead. Yeah.
Okay, yeah. Thank you, everyone, for joining in today. It's a pleasure to be here at HashiTalk India again. I'm Nikita Maurya. I'm really excited to share infra as code mid prompt engineering, AI-powered Terraform workflow. Just a minute. Let me reshare, please. Okay. So yeah, a big thank you to HashiTalk India, and we have covered today. We are covering today infra called meet prompt engineering, AI-powered Terraform workflow. So about me, I'm Nikita Maurya, staff cloud platform engineer at AppDirect. I do have 8 years of
Sorry to interrupt,
experience.
Nikita, could you please share your screen and put your slides on screen like a slideshow mode, please?
Oh, so sorry for that. Let
No
me
problem.
share again.
Take your time. Yeah. Sometimes it happens, right? So yeah, don't get nervous. Like take your time and share it
Yeah.
whenever you're
Okay.
ready. Yeah.
I hope you guys can see my screen.
Yes, please put it in slideshow, please. Yeah, that's
Okay.
great.
That's better. Okay. Yes. So yes, I am Nikita Maurya, staff cloud platform engineer at AppDirect, and I am again this year coming in HashiTalk India. This is my second time here, and I can say I have 8 years of experience in cloud migration infrastructure, and I am a solution architect professional, Terraform associate, and this year I did AI cloud practitioner as an early adopter. I do share my insights on Medium, and I am a tech speaker and women in tech advocate. So that's all about me. Let's Okay. Yeah, let's go to the agenda for today. So before we begin, I'll start with the early days of infrastructure as code, and we can also share our challenges on those days, how the things were working. But we as a human, we have to deal with lot of breaking changes, and then dealt with the time and complexity. Now, I'll also discuss about the evolution, the prompt engineering arrives, and the real world use cases and techniques. After that, I'll share the end-to-end demo where I'll discuss more about prompt, code, and deploy. And we'll wrap up the session with key learning and key takeaways. So, yeah. So, the early days of infrastructure as code. Okay, so let's rewind to the early days of Terraform. So before AI entered the workflow, back then even a small change meant like Terraform doc, checking the provider version and searching the registry for the right syntax, right? And can we not forget this version, the major version upgrade where we migrated from like 0.11 to 1.2 and 1.3. Okay, so at that time there were a lot of breaking changes, and we have to like specifically if we have to module standardize any kind of module on those time, we have to deal with lot of syntax changes, right? So these are the time like we have to go with Terraform documentation, we have to also check the provider version, we have to also go for the registry. So if you are using any kind of public registry, we can go and then check the version itself, and then see. Okay, so every changes tested manually, every error fixed line by line on those time, and most teams still review every changes manually. Okay, so testing line by line to make sure nothing fails. So these were the time where infrastructure code means like lot of going through back and forth. But now let's see the need for change, why manual ISE wasn't enough. So too much time we spent on reading documentation, searching syntax example, repetitive Terraform code written across environment and teams. So as a cloud engineer, I can say we spent hours on reading docs, copying snippet, and making sure every module worked the same way across environment. So Terraform brought automation, but it didn't scale human efficiency, right? So we were writing the same boilerplate again and again, reviewing the same error and trying to remember which provider version broke last week. When new engineers joined, it took weeks to get them familiar with ISC pattern, and even then, they had to copy and paste from the old code. So that's how standardization blocked on that time. Now we realize something important, like we had automated our infrastructure, but not our thinking process. So we need tools that could understand intent, not just syntax. So that's where AI started and makes sense. So after that, let's understand the evolution of prompt engineering arrive. Okay, so this is not, I can say the prompt engineering is magical thing and just happened like that. It is more of a generation, and it came live. So we can say like something amazing happened, and then AI started understanding our intent. So basically when we talk about prompt engineering, we can talk about like we can see it in action, how you're adding your intent, and then we could describe what we wanted. So just an example, like create a VPC with subnet and net gateways, and we are just using a simple English, and it will understand our intent and create those code. So prompt engineering to me is like adding the proper developer intent, and there are tools like Cursor ID, GitHub Copilot, and there are like Codium, so many more in the market. Okay, now we'll also see how we can add the prompt, what are the techniques, but it also require the human and AI collaboration. So basically, it wasn't about replacing engineers; it was about collaboration. And prompt engineering because the bridge between human thought and machine generation, where we guide AI to build infrastructure the way it would. So that's all. Now let's understand this with one of the example. Here in the left you can see vague prompt, and in the right you can see well crafted prompt. So let's understand this if you add the vague prompt, like if you add the garbage in, you will get the garbage out. Okay, so basically, if you add the prompt like create an EC2 instance, so based on the training data set of model, it will give you the answer. Here, I'm not adding any kind of example, any kind of reference, and it will use based on the training data set. It will give me the example and write a code. So that is a vague prompt. So AI doesn't guess; it interprets. So if you if you're vague, you will get a vague result. If you in the right, you can see well-crafted prompt. So if you provide clear structure, context, you will get a production-ready Terraform code. Okay, so prompt engineering is basically infrastructure design. In our case, I am just using for ISE, a design through conversation. So this is a bridge between our thought process and machine understanding. Let's understand with few of the techniques, and I'll cover this technique in my demo. So zero shot prompting. So this is the most basic form of prompt engineering called zero shot prompting. Here, no example are given to the model. You simply provide an instruction or question, and the AI respond directly based on the training knowledge. It works well for simple and straightforward tasks like generating a definition, translating text, summarizing short content. Okay, but it has a clear limitation. So since the model relies only its in existing knowledge, it may not reason deeply, handle complex and context accurately. So basically it is for a basic translation or definition, or the task that I showed in my previous slide, like create a EC2 instance or a VPC. Okay, we'll see more in our demo. Next, uh, check few shot prompting. So few shot is like guiding LLM with example before asking for a new task. So let's say there are other shot prompting is like one shot. So basically one shot or few shot, like you are guiding the LLM with few of the example, and LLM follows those pattern and generate the similar result in your module. So let's say you have hundreds of module and you want to apply few of the tagging that we will see in our demo, and you are giving those pattern to your be it cursor, be it copilot, and what AI does, it will follow the similar pattern and create the similar kind of a structure in your module or a structure that you provide in a reference. So this ensure consistency, reusability, and compliance. Without manually updating hundreds of files, we can directly use this prompting and see. Now, the last one is chain of thought prompting. So basically, this technique is called chain of thought, and it is all about helping the model reason step by step. So instead of jumping straight to an answer, we instruct the AI to explain its thought process, similar how we would solve a problem by writing out each step before reaching a conclusion. So I guess many of you might be like, everybody is using ChatGPT, Gemini. So if you're adding any complex pattern and if you're asking any complex question, it took some time. Okay, and you can see like in that particular screen, it is showing thinking, and there are sometimes it also show like reasoning. Okay, so what it does, it is using the step by step method where it can apply the multi-step reasoning task. So it is especially useful for math, logic, planning, or any multi-step reasoning task where the model needs to connect ideas instead of just recalling information. Okay, by making reasoning explicit, this model reduce mistake and hallucination. So since the model has to justify each step it takes, of course the trade-off, right? So is that response can be slower, but accuracy and transparency you get in return just make it absolutely worth it. Okay, so when precision matters, chain of thought is the technique to rely on. So let's see in our demo. So let me know if you see my screen for the demo. I have prepared it here. Okay, so this is okay. So I am using cursor as a IDE, and here I am using the free plan. You can see, and here there is an option to upgrade the plan, but I am using the free version. Upgrade to Pro and upgrade to Ultra. Now I'm using I'm using it day by day, so that's why I'm just showing it here. And you can see if you're using VS Code, you can directly import all the setting. from here, and it is like just one click and you are good to go. Now, yes. Yeah, so there are some other models. Now we can see the models here. So here we can see OpenAI, like ChatGPT by OpenAI. You can see GPT-5. You can see models from Anthropic, Sonnet, Cloud. So there are many models. Now, if I want to enable any other model for my agent, I can directly toggle on. So these are the things. Now, if you can see, there are tools in MCP. So if you really want to create your own MCP server or use the Terraform own MCP server, you can use it. Now for this demo, I have prepared like three folder, one for zero shot, another for few shot, and third we will see for chain of thought. See this, I am using zero shot. I have just added one prompt here, deploy a simple web server on AWS using Terraform. Okay, so here you can see the agent mode. So agent mode will directly plan, search, and build anything. So based on your repository that you are selecting, it will directly add, suggest the configuration and do the changes. You can also go for the plan mode and the cursor ask mode. Okay, so these are the things. So now if I select this deploy a simple web server on AWS using Terraform, I can copy here in the chat, and I'm just referencing. So for reference, you can directly select the folder. Okay, so here I have selected zero shot because I want my files to be issued here only. Okay, so here just remember one thing, I'm not adding any kind of example, I'm not providing any kind of pattern here. That's why it is zero shot, not providing anything. So based on the agent uh, foundation model it use, and based on the agent it will create the files. Okay, so here you can see the to-do list, create Terraform provider, and it is using zero shot folder, and it is creating like for web server what is required, a security group and user data. So I haven't added provided like anything about Nginx server, like create this. So let's see how it create the file. Okay, so you can see it added all the details and also giving me the information about Terraform init, plan, apply in the prompt.md. So we can use it that. But the main focus is like adding those files so we can see the changes here. Okay, so let's go to the main.tf. So basically here it is created the security group for my web server, and here it use the local as a user data, and here it uses web server for AWS instances. Okay, and I haven't mentioned any kind of AMI, so it is just created a one template, and it is also adding the output because I need the web URL and the assigned public IP. So this is the showcase for zero shot, where you can just add the simple prompt, and based on your intent it will create the references. Okay, so this is all about zero shot. Let's select second one, few shot. Okay, so I'm just closing this. Yeah, now in few shot. So here I have prepared one thing. I have created a module only. So I have created two module, one for EC2 and one for S3 bucket. So basically I am already have my main file, output and variable. Here you can see my AWS instance is already there, and I'm using some dynamic variable for the security group, and the data for AMI, and I'm also using output and variable. And similarly, I have main.tf and output and variable. So basically, I'm creating S3 bucket. For those, I'm attaching S3 bucket policy, access, and versioning. Okay. So, and here you can see I have already added the tags. So the tag is basically in general. I'm not specifying anything. Now what I want, I'm giving this sample. So this is one of the pattern that my AI to follow. So basically I am giving this prompt apply tagging standard in all the resource block. So here I need to provide where I want to uh, add the tagging. So I will add here the specifically module. So here I have to select those. So here you can see HashiTalk India, few shot and modules. I'm selecting the folder and I'm giving this pattern. So basically if you copy this code, it will directly auto select here. You can see it is giving like one line number 1 to 5. Okay, and let's see. So let me show you directly. Okay, so it is first checking my scanning the existing repo. So it is scanning EC2 and S3 module, what it has currently, and the tags I already added here, but I want my tags to be updated based on the syntax or based on the pattern that I'm applying. Okay, so it is just checking all the things here, but let's see. Okay. Okay, let me show, I guess we the chain of thought. So yeah, so you can see, so for this here, you can see it is applying the tagging here in the main.tf only. Okay, so this is the tagging structure that I want to follow, and this is applying it here in the few shot. So basically, I'm giving and providing an example, and it is following the similar pattern. Now let's come to the third chain of thought. So here I have prepared for chain of thought is I have already created an EC2 instances, and here if you see the EC2 instances is only created, and we have already added some dynamic and security group. Okay, now I will and this is the output and variable. So basically, as we already discussed, chain of thought is mostly where we can apply the reasoning. So what I want, I am just adding the prompt, review the Terraform configuration and reason step by step which part of this setup can be optimized for scalability and cost. Explain your reasoning clearly and then refactor the Terraform code. So I want just go and check my Terraform code and explain the reasoning. Use variable driven instance and use auto scaling to support auto scaling group, and output block also where you can public the DNS health. So here I have added all the details, and I want my Terraform code to be updated as per auto scaling support and create a load balancer because we have to test it with the load balancer now. So currently, if you see here, it is planning the next move. So basically, first it will review the code and refactor it. First, it is reading it because this is a complex pattern that I'm asking. First, it is reading, and then based on my input that I have added in a prompt, I'm asking to create auto scaling group and load balancer. Okay, so here you can see it is taking some time because there is the steps attached with it. Okay, so it is like adding auto scaling support with launch template and ALB, make instance creation variable for ASG and subnet, and it will also update the ALB DNS where auto scaling is enabled. So you can see now it is using as a count because we have to enable auto scaling or not. That's why it is automatically using variable, and you can see the subnet and instance is already updated. Similarly, weight is also updating for the output. And now what we ask, so it is providing step-by-step reasoning on the scalability and cost. So it is also suggesting the health check, okay, exposing instance directly, and then provide health check, connection draining, even traffic distribution. So this is the thing, and the cost wise also. Okay, and it is also showing what I changed, and this is the updated Terraform code. So basically it is taking time. So as we discussed, the slower the trade-off will be slow, but based on the accuracy and based on the intent that we have updated, it will create the whole skeleton and check the existing Terraform rep also. So this is the power of chain of thought. We can apply it for the bigger use case like this, and maybe we can also use it for three-tier architecture or existing where we have to migrate from three-tier old Terraform repo to Terraform Cloud or Terraform Enterprises. We can use this chain of thought prompt techniques. So here you can see it is created auto scaling group. It is also created load balancer, attach the target health, so on and so forth. So this is the power of chain of thought, and similarly, it is also applied the public IP and web DNS name. So I'm just keeping it all. So that's all about my demo. Let's go back to key learning and key takeaways. So basically, let's prompt are the bridge between human and LLM. So they translate our intent into machine understanding. So just understand like good design equals better result. So just like Terraform module, a clear prompt structure leads to consistent outcome. And we can use smarter techniques like zero shot, few shot, and chain of thought to improve our reasoning, and we can tackle the hallucination using fact checking. So if you like as I already mentioned in the start, that we studied with lot of documentation, but as there are a lot of AI powered tool, there is still we can also use the fact checking, what are the syntax using the documentation. Yes, it is helping us, but keeping human in the loop is always and always be a good real intelligence when we come to AI plus human collaboration. And balance, we can balance the creativity and accuracy. But yeah, one more thing, secure prompting is very important. We have to respect the sanitize and input, protect secrets, and respect data boundaries, and make sure that you won't add or commit any secrets. So that is more on the grid side. So yeah, while AI generates, human insight guides and validates, gives context. So that's all about. And yes, thank you so much for joining me today. And I hope this session gave you a new perspective how AI and prompt engineering are evolving as infrastructure as code. If you like to stay connect or discuss more, feel free to scan LinkedIn QR and on the screen. I would love to connect and exchange idea. And big thanks to HashiTalk India and everyone watching. It's been great sharing this session with all of you. So thank you.
Yes, so that was a very insightful and much needed session for today, right, in the AI era. Thank you, Nikita. And Nikita's session was very insightful, and she explained how we can use AI LLM for generating infrastructure as a code. And she also covered various prompting techniques and a very good comprehensive demo. This is one of the much needed topic of the current AI era, where we can use Gen AI and LLM for increasing our daily productivity. Most importantly, she also covered the best practices aspect of keeping human in the loop and other aspects, right? So it was a very insightful session, Nikita. Thank you for that. And let's have a quick announcement. So mark your calendars for HashiTalks 2026, the 8th annual 24-hour virtual event for HashiCorp users that follows the sun will take place February 19 to 20, right? It's a 24-hour session. Visit the hashitalks.co and the provided link in the display to register and submit a talk. It is a very good opportunity to show your like authority in the HashiCorp tools and infrastructure automation space, right? So next up we have Divyanshu Misra. He is going to talk about Terraform at scale, managing 100 plus modules across the teams. So if I can quickly introduce Divyanshu, he is having 6+ years of experience in IT, and he has worked at Capgemini and various organizations, now with GCP Partner 66 degrees. And he worked on projects in public, hybrid cloud, and private cloud environment. And let's hear from Divyanshu on what he's having us for us today.
Hello. Thanks, Evan, for this quick introduction. I hope you guys can hear me. Just a quick thumbs up from someone can help. Okay. So I'm Divyanshu again. I hope you are having a good time till now with few good sessions out there. And today I'll be talking about another session which is about how and what Terraform will look like when you will be going to scale it. So we all know that today it's not about that, okay, whenever you are going to work for a company as a DevOps or as a SRE engineer, so you will have a module to manage or you will write few lines of code just like how we do while loading. So that's not how things work. Usually it's a huge infrastructure. When you get in, you get your credentials, you get your accesses, and then you have to take care of entire the infrastructure, how it look like, where are the modules, how many teams are involved. So at times, whatever we have learned sounds very easy. However, whenever we go into the production, things look more tricky and different. So hence, my topic is more about how we can manage. I would say not 100 plus exactly, but many modules if you are managing as a part of a team wherein you are working as a DevOps engineer or an SRE. So there are a few content I prepared that what are the key pointers I'll cover in my quick session. So one starting will be giving the problem, what exactly my context will be, on what topic I will be discussing. Then we'll discuss about the scale and complexity. Furthermore, we'll discuss about what is how our architecture approach will look like and what are the best practices we can go ahead and do. Governance, of course, comes as one of the key topics when we talk about this thing. Apart from that, one more thing which we'll be discussing is about how the typical tools, or you can say the automation things which we can take care of while doing this. Okay. So I'll start with, if you see the slide, so of course we all know that, okay, and a very layman, Terraform is nothing just about, it's a ISE tool. It's help us to manage or deploy resources on any cloud platform or any other platform wherein whatever we are doing manually, we are doing via code. So people say it's a kind of an automation. People say it's how we can reduce human errors. It's how we can scale, because we need not to write everything again and again, or we need not to do everything on ClickOps thing, because that may prone to human errors. So now whenever the code strength increases, be it, let's say, if you are a developer also, you might see that, okay, when you write a lot of code, things may not go in the way you want it. Hence, it's always wise and how you are managing it. So you need to ensure that not only the technical part is important, but also how you are keeping track of how things should work and move. Okay, so when we say in a very small scale setup, let's say we are a team of few people and we're having small infrastructure, or let's say we are managing client which is not having a huge Terraform infrastructure, it's quite easy to manage. There are few modules, there are few environments, and there are few resources, and you are deploying it consistently, regularly, or maybe managing it or shuffling it as and when required. However, there are chances, or there are cases wherein you are working for a company, you are working for a team XYZ. There are other teams also which are together managing the same infrastructure. They have been named differently, that, okay, these guys are from platform, these guys are from SRE, these guys are from automation, or they do the scripting and all these things. So now whenever there are multiple people involved in different teams, so the count may of course go to a certain level. Plus, there are many problems that come along with it. I would not say problem in the first place, but I would say many complexity comes along with. So few challenges which everyone faces, I think you might have faced already. It's one is that about duplication of a module. Suppose team A have built a module about a VPC or a VNet. Similarly, team B is also creating. Okay, so the agenda may be different, or maybe these two VPCs are being used differently, but that is something which can create some sort of issues while you are managing it going forward. Because suppose I want to do some changes, that does not mean the other buy is also making some changes. So the naming convention we need to take care of. For a customer, let's say we are managing customer ABC, so there should be proper naming convention which we should take care. It's not like everyone is pushing the code. Of course, code will go live. There won't be any issues. But going forward, as people will come along, people will replace, things may not go the way it should be. So there should be places where it could be inconsistent standards. You will find updates will be slow, and you might see that okay, there are some different versioning. Suppose my team have decided that okay, we will be going ahead with version 1.24 for our Terraform code, which we are managing for all the repos and everything, and we did it. But that does not mean everyone others in the other team who are also managing the same infrastructure have done so. So that also we need to take care. But whatever we are doing for the benefit of the customer or for the benefit of our team, that should be going in a way which is very smooth and with clear ownership that okay, who will be doing what. And if not, if you're not doing also, you need to ensure you are uh, informing people who should be ideally informed, because by that way the customer is also aware what is happening around their infrastructure, plus the other people who may have to take some steps as a proactive measures, so they can also take care of that. Then with people say okay, CI/CD is something which can make my things smooth, they can make my things very quick to do, but at times they can also choke. The CI/CD pipelines can also have hard to manage. So this is a quick setup how our single team setup, or maybe how learning setup will look like. Whenever we have learned Terraform in our earlier times, we might have seen that okay, there's a single team, or let's say I'm a one user. I have created some docs. I have created some Terraform code. I have a demo infrastructure wherein I'm just getting resources, VPC, compute, storage. Everything will go live. Terraform plan apply. Everything will work smooth. However, in reality, whenever you are working for an organization, you see there are many teams, there are many modules. So, like I said, VPC, or let's say there are some few basic components, or I would say basic networking components. On top of it, the every infrastructure, comes along with. So we need to take care of every minute details, how our naming should look like, how the entire pipeline should look like, how my flow will look like, and if there is a point of wherein we can use our code, which is we have learned in oops also, which is called inheritance. So inheritance is not just about getting the code, it's more about reducing the complexity of space and time, that you are not writing the code redundantly again and again, but utilizing it in the best fashion way. Okay, so with more teams, with more modules, things can become tricky, so the scaling at times become an issue in that case. So okay, so we need to understand when we scale things, it's not about just adding more resources or adding more code into it. There are many other things that come along with. So we need to ensure consistency is not broken. If there are more repos, there are people's at one place might have been using mono repo thing, wherein they're writing everything in single repo. They might have created different environments in the form of dev, prod, or you can say QA, but they are writing everything in one shot sort of thing. However, the other side of people might be doing in some other way. They might have created different mono repo. They have created different repos for everything. So they might have created some silos, which eventually have their own benefits. So the approach which you are taking is not always correct or wrong. It's more about how you are effectively implementing in your organization or in your team, so that everyone is aware and how things should move. So the main key areas, how or what are the key challenges which comes when we scale? It's more about the complexity of the code, then the coordination. There are teams who might be working 24/7. Also, there are people who are working from some other part of the nation or other part of the globe. So you need to ensure everyone is aware, even if he's working from European hours, if he's working from US hours. So whatever changes we are doing, so it should be streamlined in a way. Suppose I have done some XYZ thing in my Indian ICE time. So when I give the handover, though they should also be clear and aware that okay, how I should take it ahead from one place to other. So in that case, the coordination becomes a key role. Then the governance, of course, governance at times might sound that okay, this is something which is always keeping an eye on us, but that's not the case. It's more about how you are implementing those changes, how you are implementing some policies. Suppose you have created some own set of policies that okay, for these kind of people, this should be the IAM roles, like we have learned in GCP also, the concept of least privileges. So then to ensure only the necessary people should have necessary accesses. Then we do in turns also control how we are managing our Git repo or our version controlling tool. So who are the people who can approve the request? It should not be like that okay, today I have done some changes, I just raise a request and anyone can approve it. So that governance can also helps to ensure our code is secure, because at times people who are not very known, they might see something else and they might just approve changes which are not supposed to be good for the infrastructure. So that's why governance is also necessary. Then comes the performance and automation. Automation is a very I would say a term which is known across industries, well accepted, well used, but it have its own pros and cons in terms of how you are using it. Whenever you are deploying something resource, some resources, or anything out there, there are a lot many hiccups that may arise before and after it. So you need to ensure whenever you are scaling, your workflow should be very smooth and accurate. So, like I discussed again, this is just you can say visual representation of how our problem might look like. With modules, people say that okay, modules is a kind of a reusable code. So instead of writing code, I will use it again. But we need to also define how modules within all these modules have been taken care, have been written, and how they have been flowing from one place to other. There might times be that okay, there might be some clashes in terms of two modules written in a similar way. They might be used interchangeably, but they are not being used. So there could be some violation in terms of policies. There could be a module drift, which is more about this repetitive set of modules. Apart from that, this is a basic thing which we learn about how the issues may come across. But now we'll discuss about how to win this case. I mean, if there are some situations out there, or if you are already working to infrastructure, or you are starting from scratch, how your design should look like so that you can you know uh, go through all these challenges which we have discussed in the previous slides. So our architecture approach should be very clear in terms of how we are defining your core modules, feature modules, and environmental modules. And don't take it go with the names. It's more about just understanding that how my see, whenever you are starting from a for any Terraform, let's say, deployment, if you were creating a new infrastructure, the customer has recently onboarded. So the plan should be, the agenda should be that okay, today we are starting maybe with n number of resources. In future, we may go beyond any scale, so things may move to at any certain level. So we need to ensure that we are creating an infrastructure which is quite scalable in terms of everything. I mean, from a very minute details about how your naming should look like, then how your file structure should look like, how your folder structure should look like, and how your core databases or maybe core modules look like. If it's a data driven company, you need to ensure that okay, they will be heavily relying on data. So that should be made from scratch in a way that it can be easily scalable. So there are certain ways which we can ensure that there are few modules on top of it, other module resist, or you can say there are few things on top of it, other resources are created. So network, as we know, is storage. These are very basic components. On top of it, every other resources are created these days or ever in history as well. So even in an era wherein there was no virtualization, there was data center thing. The first and foremost thing was having physical boxes in a data centers. On top of it, creating the network pipeline, wherein how you are putting physical cables out there just to ensure every box is well connected. So that was the first and key component or key you can task before deploying any data center out there. So we need to understand what are the basic principles. Like I've been discussing along, that versioning should be very correct in terms of if you are upgrading, go in a certain fashion that everything around your infrastructure should be on same version. Versioning is also about how your code is being implemented. Make sure your previous code is immutable. Suppose there were some n number of errors out there in your code written on October 2025, but if you are releasing every version on 15th of, let's say, month, so the November version should be with all the changes, but the October version should be kept intact. At times, to troubleshoot, you need to see that okay, what are things I can do now in order to ensure if anything is going wrong, and if you have some learnings from your previous module or previous history or version, you can easily improvise on that part and can proceed. So shared registry also helps. How that okay, there are few data which is always useful, so you want to keep a track of it, all the copies you are managing in a certain place, so that whenever in the later run, or maybe someone else, or maybe we are creating another duplicate infrastructure similar to that, so we can use it. So shared registry helps to ensure every team out there have a access on it, and whenever they can use as a single source of truth to ensure they want to create a make some new design, so they can utilize the design which we have earlier created and can furthermore utilize it. So this is how our basic infra should look like. We'll start with the module registry at the bottom. So that includes where exactly my storage will take place, all the modules, all the governance, everything will be taking place. On top of it, there will be core modules. Core modules is more about, like I said, for any infrastructure, network, log, IAM, and logging. These are the basic components which are required. Okay, so we'll create few core modules, and this will be, taken care as a, you can say, the primary modules out there. Furthermore, based on the customer specific requirements. There will be some feature modules which will be more about only the components which are not regularly used, or maybe are only customer driven. That okay, this customer might be using AKS in Azure, they might be using some DB, let's say Postgre for any XYZ customer, and they might be using apps. So even if I replicate this infrastructure from one place to other customers, the core will remain the same, the environmental layer will remain the same. Only feature will be fluctuating as per the requirement. So there are a few things which we can keep it as a standard for our company also as a service. Let's say we are a service provider for 10 number of customers. So even in our sales page, we can ensure that, okay, this is how we take care of the infrastructure. So we can easily make other understand how we will be taking care of your infrastructure and how we are ensuring security, scalability, and everything out there. Furthermore, we'll be discussing how your model design will look like if you want to create the best out of it. There's a basic flow that you will develop the things, you will validate if it is working fine, you will test, you will doing some versioning. Versioning helps in terms of also keeping care that okay, if there are versions, there are updates which you do in the second place first, but before that there are some versioning which are done by the vendor itself. So if you are using n number of product based companies in your work, let's say you're using uh, Postgre, you are using Oracle SQL, you are using GCP also, you are using Terraform, you are using PowerShell. So those come also with some updates, and on top of it, you need to ensure how and when is the best time for your infrastructure to scale to a next version out there. So versioning is a very key out there, and you should be taking care of that part very seriously in terms of keeping in mind the security context also, because as you go forward, the support for the previous versions go in vain, and so they are not very useful. Standardization, like I said, the naming, the tagging, that variable convention should be very smooth and clear. It should not be very, you can say, standard or very common that okay, this is a BPC. So you need to ensure if it is a BPC, it is for which infrastructure, because the person who is managing the pipelines out there in the form of CI/CD, he might be using Jenkins or Azure DevOps or Cloud or whatever it is. He or she should be very clear about for which infrastructure he's pushing the code, and by any means, he or she should not push the code to a wrong repo. So then standardization is a very, you can say, good part of communication, which is very useful in when you talk about this thing. Furthermore, we will discuss about what are the governance and version management thing and how they're useful. When I say governance, like we also discussed earlier, it's more about keeping an eye on the bird eye view so that everything is going smooth. So we need to ensure testing is done well. We need to ensure the CI/CD promotion is going in a proper sequence. You are doing some changes in dev, you should go then to staging, then to prod. Going straight away to skipping or any stage won't be useful. It might make sense to some extent at once or twice, but eventually this is not the right way of doing it. So always go ahead for a promotion in a promotion way, wherein you are moving from a non-prod infrastructure to a prod infrastructure, whatever you're doing it. Of course, policy as code. I think there was one other session earlier about IAC. And then there was a topic called, I think, OAC. That is about OPA. So whenever you're doing that, you are just ensuring that, okay, there are few policies which should be implemented, and those policies should be taken care while deploying the resources. And this will also ensure your resources are well governed and well managed. This is the similar or the same thing which we have discussed in the previous slide. I think we are okay. One of the final things which we before wrapping is more about how the collaboration will look like and why it is needful. So whenever you do collaboration, it should be in terms of clear communication. It should be you need to ensure how well you are keeping documentation. I think we can all agree that okay, whenever we are stuck in any technical issues out there, we often prefer going ahead to the official documentation from the Google, Microsoft, or any big giant, you name it, because they have maintained those documentation in a way that even if you follow those, you will have a clear understanding how things work. Even if you are stuck to a point X, then you have n number of solutions in a very well defined way. So hence, this documentation is very helpful and needed times. Code reviews, like I said, this is a very known practice, so this we should not talk much about it on that part. Communication, like I said, not every communication can be formal on emails or way. There are few communication which should be done on a way wherein the person who want to share some information and the person who are the receiver should be sync, and they should discuss with among themselves. It could be on Slack also, it could be with some comments also, or maybe it could be in the form of any other medium by which they are comfortable with. Okay, then furthermore, you can also enhance those collaborations by creating some modules, or you can say using some different tools for metric dashboard. Suppose you have created a deposit. Okay, how many people have raised wrong pull request out there? So if you are keeping track of all the mistakes which have been taken care using some dashboards technically only, or maybe you are using some feedback loops, so you can improvise going forward that okay, last time we have done this amount of mistake, but this time we can reduce it. Then when we talk about the tooling and automation in the final another stage, it's more about how and what are the tools which you can use in terms of scaling. So there's a very good tool I was reading quite some time ago, which is about renovate bot. It's a dependency update tool which is can help you to understand how your dependency will look like. Then if you want to discuss about the drift detection, you can go ahead for the automated plan thing. This is also a very good tool. And also you can also use alert triggers to identify if whatever your expectations are not being fed up. Then you can get the alerts that okay, these two modules are colliding somewhere else, or maybe these two resources are having similar names, or they are colliding in some way which is not good for the infrastructure. So a view of how your infrastructure is going ahead and improving, so you can also have a look on that part. So, like I said, before all these closing this, there are few things which we have learned out there. It's more about how you are, validating your request, how you are governing your things, and how you are keeping things standard. Technically, you can write code for everything, but even if you are observing the recent outages, the one which is going around in AWS, and I think there was a recent update on Azure also. So these guys have not done anything wrong purposely, or maybe they have lack of knowledge. It's more about they might have missed some tricks out there in communicating well, or maybe taking things seriously well, and hence the outages are coming and impacting huge amount of people. So if you're doing good collaboration and good understanding between the people, then I think things can go smooth and in a good fashion. Yeah. So this is the final diagram, which before I close, which is about how your infrastructure works if you're having with multiple teams. So there is a platform engineers who are creating everything. They have put it into a form of Terraform modules, compute modules, or you can say network modules. On top of it, the other engineers, the other team like dev team, ops team, and QA team are using the pull requesting and creating the modules based on your requirement. They are using the ones they have been getting from the platform team, and then furthermore they are writing only those modules which are required. And by this way, every team is aware that okay, from where what modules to fetch in order to use and deploy the resources for XYZ customer. So I hope it was time is up. So anything else if you have, please do feel free to ask the questions in the comment section. And I hope it was okay to conclude now. Thanks everyone. Please take care.
Yeah, so thank you, Divyanshu. So it was a very great talk. So as we all know, modules are the heart of Terraform implementation, and modules helps reducing the code redundancy, and it can help to templatizing the TF code, right? And modules can help do the version controlling for the various infrastructure to do the easy rollback. And Divyanshu also talked about the real-time example and use cases for managing the modules. It was a great talk, Divyanshu. Thank you for your contribution today. And next up, we have Anika Maurya. She is going to talk about from monolith to modular, scaling cloud infrastructure with Terraform, and the power of workspaces. So just to introduce Kanika, Kanika comes up with various experience, 6+ years of experience in cloud engineering, and she's working as a cloud platform engineer at JB Morgan Chase. Her expertise expands from multi-cloud, GitOps, DevSecOps integration. So now let's hear from Kanika, and over to you, Kanika.
Thank you so much, Ravana, for the introduction. Let me quickly share my screen. Let me know once my screen is visible. So hello everyone. I hope you all are having a great day and enjoying this session so far. Today I'll take you on a journey from monolith Terraform setup to a modular, scalable, and well-governed infrastructure. So whether you're managing a single cloud account or multi-account setup, I'll explain how to simplify complexity and scale Terraform confidently. So before we dive into the session, let me take a moment to introduce myself. I'm Kanika Maurya. I currently work as a cloud platform engineer at JP Morgan, and I have 6 years of experience. And my work revolves around Terraform, AWS Cloud, Azure, Kubernetes, pipelines, and all. And outside of my professional role, I'm an active tech speaker and absolutely love contributing to the community. So whether it's through meetup, conference like this one, or mentoring aspiring engineers. So I'm passionate about creating space where people can share, learn, and grow together in tech. So with that, let me walk you through what we'll be covering today. Let's take a quick look at what we'll be explaining. So we'll start by understanding Terraform, then we'll move on to the monolithic Terraform setup. The way many teams start out, right? And it worked initially, but as your infrastructure grow, it starts showing cracks, which led us to the challenges. So that come with the monolithic setup. And after that, we'll see how to overcome those limitations through modularization and explore the different ways to use the Terraform modules. Then we'll see workspaces and how they can make multi-environment management simple and scalable. And toward the end, we'll touch on the Sentinel and understand how it helped to enforce governance and compliance. And then finally, we'll wrap up with the key takeaway. So let's kick off the session. Okay, so let's start with the foundation, which is Terraform itself. Terraform, as many of you might already know, it's an open source infrastructure as code tool developed by HashiCorp. It is designed to automate infrastructure provisioning, whether you are, using cloud, be it AWS, Azure, GCP, or even on-prem environment. So the key idea behind Terraform is that you have to define and manage your infrastructure declarative through code. That means instead of manually creating the server, database, or network from the console, you can simply describe what you want in configuration file, and your Terraform takes care of that. And the beauty of this approach is that this is cloud agnostic. So you can manage resource across different cloud providers and using the simple language and workflow. So whether you're deploying to AWS, Azure, your Terraform code basically, the structure, whatever you will follow, and the workflow remain consistent. And Terraform uses HCL language, which is HashiCorp configuration language, which is clean and simple and human readable. So it is designed to make your infrastructure easy to understand and maintain even for large and complex environments. Then, if you remember in this slide, just a minute. Okay. I want to take a moment to explain what is happening here in the image which I have added. So here you can see there is a Terraform project, okay, which contains the Terraform configuration file and state file. So we'll talk about the state file in later slide, but let me keep my focus on configurations. So this is where you are defining your configuration or infrastructure, whatever you want. And once you are done with that, what you can do, you can use the commands which Terraform offers to plan or validate your changes or whatever you're trying to create. So using the Terraform plan command, you can simply, go to this Terraform plan, you can hit that, and then it will show you what whatever you have written in your configuration file, so and what it will create or destroy. And once you are satisfied with the plan, you can do the apply. So whatever target or destinations you have added in your provider, it will try to create those resources into the respective destination. Let's talk more about the configuration file. So what happened here, okay, so here in the configuration file, every file inside the folder, which you can see here, okay, has a specific purpose. And whatever you define with .tf, right, it will take that into consideration and it will start using that to create your infrastructure. So let me quickly go through the each file and tell you what it does. So basically main.tf, what I'm trying to do here is, this is your core file, okay? And this is where you define your actual infrastructure, be it VPC, EC2 or S3 bucket or whatever resources you want to take up. Then variables.tf, this file actually declare your input variable and it makes your configuration flexible and reuse. And provider.tf, this is where you will add your providers, whether AWS, Azure or GCP or anything other than that if you want to use. And version.tf, this help you to define your Terraform and provider versions, okay, so that it ensure that you have the consistent versions across environments. Moving on, Terraform state file. So this Terraform state file actually, it help you to keep the track of what already built and what you will try to build. So that will be captured inside this Terraform state file. So Terraform uses this file called terraform.tf state to maintain a detailed record of your deployment infrastructures. So you can think of this file as a Terraform memory, or it is a single source of truth. It know exactly what exists in your environment and how it maps to your code, whatever you have written. For example, you have created an EC2 instance or an S3 bucket. So the state file stores its resource ID, dependency, metadata, or even the relationship between those resources. So this is what allows Terraform to know the difference between what is already provisioned and what needs to change when you run another Terraform apply. And by default, Terraform stores this file locally in your working directory, typically as terraform.tf state. But as your project grow and you want to keep that into a remote backend, you can even do that. Let's take an example, okay? Let's create this session a bit more realistic, okay? Suppose you are a cloud engineer and you have just a requirement to create few essential resources, okay? As shown in the image, suppose you got a requirement to create S3 bucket, security group, VPC, EC2 instance. So at first, this seems like a simple and straightforward task, right? So you open your code editor and start writing your Terraform configuration to define all these resources together in a single file. Now you'll think, all right, let me just write everything in a single place and it will be easier to manage and quick to deploy, right? But honestly, this is how most of the Terraform journey began. Almost everyone starts this way. A single configuration file that handle the entire setup. It worked beautifully in the beginning, especially when the infra is small and team is just of one or more or 2%, right? But over the time, as more resources, environment, and developers get added, this approach start to show cracks, right? So let's take a look at what single configuration file or the monolithic setup looks like. So here I have attached a snapshot of code which I was trying to create and show it to all of you how the monolithic Terraform setup looks like. So suppose the engineer which we have seen into the earlier slide, she open her editor and start writing everything in a single Terraform configuration file. So as you can see here, she has started writing all the resources, the VPC, subnet, security group, and let me show you slide as well. Here, also adding the compute instances and the S3 bucket resources. So what's the problem here? So in early stage, this approach feels convenient. There are just one state file, one directory, and one person managing it. But you don't have to worry about the complex model structure or dependency. But here the stories start to change. Challenges. So let's see what are the challenges this monolithic Terraform setup throws to us. The first issue is that everything lives inside one massive code base. There's no clear separation between resources, networking, compute, storage. Everything is tightly coupled. It becomes very hard to manage or troubleshoot, right? Because a small change in one place can unexpectedly affect another. Next, we have slow plan and apply time. Since Terraform has to evaluate every single resources in that huge configuration, right? So even a minor change, like suppose updating a tag, triggers a full Terraform plan across the entire infrastructure. So things get even trickier when you introduce multiple environments like dev, test, and prod. So instead of having a separate isolated state, all of them often share same configuration and same state file. And when even more engineers join in, you start seeing team conflict. Over time, all of this make the setup hard to scale, hard to maintain, and extremely risky to modify. So even though the monolithic approach was fine for an engineer in a small setup, it does not hold up when you need collaboration, right? So this is all the challenges we see. So what comes as a savior for us? Modularization. Modularization simply means breaking the large and single Terraform configurations into small, reusable components, what we call modules. Each module is like a building block that represent one logical piece of infrastructure. For example, you might have one module of your VPC, another for EC2 instance, and one for S3, okay, and maybe another for IAM role. So instead of repeating the same code across multiple environment or project, you define a module once and then reuse everywhere, okay, whenever you need, just by calling it. So think of a module as a mini blueprint. Each one encapsulates its own logic with clear defined input like region or instant type or CIDR block, and outputs like subnet ID, IP addresses, or bucket name. So this approach make your infrastructure not only consistent and scalable, but also version control. You can also lock versions of module to ensure everyone is deploying the same tested configurations. So that's how modularization brings the structure and maintainability to your Terraform code. Okay, moving on to the next slide. So as we discussed what is modularization and how it comes as a saviors from the monolithic setup, we'll see ways to use the Terraform module. Currently, in this slide, I'm starting with the local module. Local modules are modules that are stored inside your Terraform configuration project itself. So they are perfect when you just start to modularize your infrastructure or when you want to keep everything self-contained. So in this snapshot of code where I've attached, you can see I am creating local modules named as compute, network, or storage. And in the root main.tf, I'm simply calling those modules, right? So typically, you can create a folder called modules and you can name it as per your logical component. Like I have named it here network for VPCs and compute for EC2 and S3. For S3, I have named it as storage. Now, each of these subfolder behave like its own small Terraform project. It has its own main.tf, variable.tf, and output.tf. Let me show it to you, the breakdown of each module component I've created. So you can see here I have the main.tf and output and variable.tf of each modules. Okay, so we have the storage module which defines the S3 bucket, if you can see it here, and we have the network which create VPCs and subnet, and inside the compute module I am trying to create an EC2 instance with the security group. So this modular layout is much more scalable than the earlier monolithic setup, where you can add, update, or reuse any component without affecting the rest of the infrastructure. Let me talk about the remote modules. So these remote modules are stored outside of your local project. As we have seen in the local module, your modules are inside the current project where you are calling it. But in the remote module, they are stored outside of your project, usually in shared locations like GitHub, Bitbucket, or even S3 bucket. Okay. So what you can do, you can you can simply pull those Terraform configuration using the source parameter. As you can see here in the snapshot I have attached, I'm simply using the source tag, source argument here and passing it the value of GitHub location. So it will simply fetch the configurations file from there. And this ref equal to version, which I have mentioned here, this part lock it to a specific version tag, which ensures that everyone using this module get the exact same tested version. The big advantage of remote module is cross-team collaborations and code standardizations. So with remote module, your team can publish pre-approved module. For example, a standard VPC or EC2 setup. For example, you need standard and the standard coded VPC setup. So instead of everyone going and writing on their own, you can create a configuration make it in a form of remote module, and publish it to the GitHub repo. And other teams can simply reference them in their own project. So this not only saves time, but also ensure every team is following the same security and architecture standard without having to reinvent the wheel. Moving on, public registry module. So after local and remote module, let's take it one step further. Okay. So Terraform has a fantastic platform called public module registry. And the link is registry.terraform.io. So that hosts thousands of pre-built and community-vetted modules created by HashiCorp, cloud provider, and even the open source community. So these modules are designed to handle common infrastructure patterns, things like VPC, S3 bucket, RDS database. So you don't have to reinvent the wheel every time you start a new project. Here it shows a VPC module, okay, being used directly from the public registry. With just these few lines of code, you are pulling a fully functional best practice AWS VPC module, complete with subnet, routing tables, and net gateways, all maintained by the Terraform community. So what's great about public module is that they are battle tested, widely used, documented, and updated regularly. They save developer time, especially for standard setups like networking, IAM roles, or load balancer. Moving on to the next slide, private registry module. So a private registry module is essentially a centralized and organized organization-wide module repository, typically hosted in Terraform Cloud or Terraform Enterprise. So here teams can publish and versions and approved module internally, just like a public repository, but with full visibility and access control within an organization. This module enables reusability, governance, and scalability. You are not just managing infrastructure anymore. You are managing a reusable infrastructure product now. So in this example, this EKS model is not pulled from the public Terraform registry. It is coming from the private internal registry, scoped to your organization. So the real power here is governance and consistency. Every module in the private registry is reviewed, approved, and version controlled before it become, available for others to use. And this setup is not only standardized infrastructure, but also improve security, compliance, and operational efficiency. So in short, private registry bring order and trust to your Terraform at scale, allowing team to move fast without breaking the governance rule. With that, let's see the benefits of Terraform modularization code. So as we have explored all the ways to consume the module, like local, remote, public, and private, let's see the benefit. So modular Terraform is like turning a cluttered toolbox into a neatly labeled compartment. Everything is organized and easy to find, right? For example, instead of writing the same VPC or EC2 code again and again for dev, test, and prod, you just build a module once and reuse it everywhere. Each module keep its own state. So if someone update the S3 bucket module, it won't break your EC2 setup. Just an example. Everyone works safely in parallel. And you can also have versions in your module. Say you are using 1.0 for productions and while testing your version 1.1 in staging, just like app releases, right? And this make updates safer, fix faster, and collaboration is smoother. Even every environment like dev, test, and prod follows the same blueprint, and you can customize it in form of using variables and other techniques. And in short, module turn a Terraform infrastructure from chaos to something predictable, reusable, and scalable. Let's see another core and important component of Terraform, which is workspaces. So Terraform Workspace provide a clear and efficient way to manage multiple environment, which we were also talking inside the modularization, right? Such as a dev, staging, or prod, and using the same configuration. So instead of duplicating your .tf file, why I'm saying .tf? Because whatever you write and ending with .tf file, Terraform consider that as a configuration language or whatever you want to create and deploy it into the respective cloud. So instead of duplicating .tf file for each environment, we can create isolated state file through workspaces, because each workspaces track its own state file independently, which means changes applied in one environment does not change or interfere with other. And the command here I have shown that illustrate that you can use Terraform works new and then your workspace name. For example, I'm using dev. So it will create different workspaces for dev, and whatever you will try to provision through these workspaces, it will create a different state file which will be different from the prod workspaces which I'm creating in second command line. And if you want to list what all workspaces you have, you can make use of Terraform workspaces list, which help you to view all the available workspaces. And the if you want to select and by default you will be in a default workspace. And if you want to select a particular workspaces, you can make use of this command Terraform workspace select and your workspace name. So this is how you can switch between the workspace and even create a new workspace. And in the second image, what I'm trying to show here is, suppose you have the configuration file, right? So you can see the directory structure here. Terraform automatically store the state file under terraform.tfstate.d folder, okay, with a separate folder for each workspace. So this approach allowed team to maintain environment isolations while still, managing everything from a single code base. Here comes the benefit of workspace. So as we have seen how powerful the workspace can be, right? And especially to isolate your state files, which is very essential when multiple teams start working together. So Terraform workspaces simplify multi-environment management by isolating the files. And as each workspace has its own state file, so there is no interference between the state file corruption issue. And using one code base across environment, you can reduce the duplications and eliminate the drift. And this isolation lead to a safer deployment also. Means if you have suppose a failed dev changes, right? So it will not impact your production because on and all state file is isolated. And it also guarantee consistency. How? Since all environment follow the same modular structure and version code, right? So this will allow that you have the same consistent code across every environment. And finally, workspace make scaling easy. So you can replicate the infrastructure across multiple regions or account with minimal effort. Now, as we have covered structure and scalability, let's talk about compliance. And here comes Sentinel. So Sentinel is a policy as code framework that integrate governance and compliance directly into your Terraform code and Terraform Enterprise. It allows organization to enforce rule and policy as code, ensuring that every Terraform change follows security and compliance standard before it deployed. So Sentinel work as a preventative control. But before moving into what it is, I'll show you or I'll talk about the two type of control which we have, detective and preventative. So detective means it will identify the violation after something is deployed. Okay. So but preventative control is done through Sentinel only. So how it is different from detective? It means it evaluates your Terraform plan or any changes before deployment and stop the non-compliant changes from being applied. And it also provides the fine-grained policy enforcement, like it will allow you to have the different enforcement level, which allow, deny, or warn based on the Terraform output you have. For example, it can enforce tagging standard, restricting instance type, or block your deployment to unapproved region. So this all can happen automatically once you start writing the Sentinel policies and apply it to your Terraform configuration file. Moving on, so Sentinel policy, how it evaluate your code, right? So as we know that whenever we write any configurations, we start with Terraform plan to see what it is creating. And once we are okay and good with it, we can simply go ahead and do the Terraform apply. And it will start creating your resources actually into the cloud. But if you want the Sentinel policy, and suppose we have created the Sentinel policy, so where it will be placed? So it placed between the plan and apply phase. It help you to evaluate the changes before actually applying it. So once your Terraform plan runs, Sentinel automatically kicks in and evaluate the plan output against the defined policy. You can create your policies according to your organization need or any requirement. and it checks if the proposed infrastructure changes follows your organization rule. And the same example I can say, like enforcing tag or approving a particular instant type. And if everything is compliant, right, Sentinel allow the apply phase to proceed. If not, it will block the deployment before any resource are created. So Sentinel evaluations act as a policy firewall, we can see, right, verifying compliance before anything is applied. Moving on, Sentinel has 3 flavors of enforcement level, okay? Advisory, soft mandate, and hard mandatory. Sentinel giving us the flexibility to restrict the policy, restrict the changes, and enforce the policy. It not only block or allow. Instead, what it does, I'll tell you. It provides 3 enforcement level as it is shown in the slide, right? So as its name suggests, advisory. This level is not blocking. Sentinel simply check the policy and give you a warning. So if something fails, right, so Terraform will allow you to apply the changes, but it will give you the warning. So that's how the advisory work. So if let's take an example, if you are the initial level of enforcing the policy and you don't want to disturb the customer or your team, you can have the policy for the first phase, which is advisory, so that people start getting it as a warning that okay, this is not the correct or not the compliant way of writing the configurations according to the policy you have created. And once you are okay, like okay, everyone knows this and they are trying to move to the better and compliance code, you can make it slowly to soft and then hard mandate. And talking about a soft mandate, as its name suggests, it enforces the rule, and if policy fail, it will block the apply. But authorized users can override it manually after review. So this is perfect for staging, or I would say test environment, where you want to enforce the standard, but still have the flexibility in exceptional cases. And the third one is hard mandatory. This is a full governed module. So if policy fail, you are done, bro. So apply will not happen. Okay, key takeaways. As we come to the end of this session, let's take a quick moment to recap the journey we have covered today and lesson learned. So we started with the idea of IAC, where automation and consistency replace the manual provisioning, enabling fast and more reliable cloud development. Then we looked on how monolithic Terraform setup, while a simple at start, can become difficult to scale and govern as infrastructure grow. And that's where modularization come in, and breaking large and complex setup into reusable and maintainable and version controlled way. Then we also explore Terraform workspaces, simplify multi-environment management, and allowing dev, test, and prod to share the same code base while keeping their state file isolated. And then finally, we saw the Sentinel bringing policy as code, enforcing governance and compliance before any resources is deployed. So in short, moving from monolithic to modular Terraform is not just a code change, right? It is a mindset shift. It transforms your setup from chaos to a better, scalable, and reusable infra. And that's bring us to the end of the session. Thank you so much for being such an amazing audience. I hope this session helped you take the next step toward building scalable, secure, and well-governed Terraform workflow. But before we wrap up, I would love to stay connected with all of you. You can scan this QR to reach me on LinkedIn. And the best part about community talk like this is the conversation that continues after the session. So let's keep that going. Thank you so much, HashiTalk India, for giving me this opportunity. Thank you.
Thank you, Kanika. So that was a very great session. And we have our co-host Adit joined us back. So if we can talk about the session what Kanika has just delivered. Kanika's session explained the various aspects of best practices on how we can use Terraform best practices, and she broke down the monolith Terraform configuration, and she explained how to modularize infrastructure as a code. She covered various registry types, use of workspaces, and she also talked about various module structure and remote state management as well. Thank you once again, Kanika. And with that session from Kanika, we are at the end of HashiTalks India 2025. It was great, another event at HashiTalks India today. Our speakers has presented very insightful talks along with useful demos, and also the topics cover the various HashiCorp technology stack and the complementary tools combined with HashiCorp technology stack. Thanks to HashiCorp for providing the opportunity to co-host the event along with Aditya and Neil, and they are a very awesome co-host. And special thanks to Jasmine for being a great showrunner for today from HashiCorp community. Over to
Couldn't
you,
agree
Aditya.
more. Yeah,
Yeah.
Saravanan, couldn't agree more with you. Like the amazing support that we've got from the backend team has been great. But I would also like to mention great session by Kanika as well. I think I
Exactly.
could get a glimpse of it at the end. But the speakers that we have had so far, brilliant speakers and great diverse topics from Terraform actions to Terraform module lifecycle to Vault Radar, and then coming back to life cycles, and then again around Terraform modules, and then Sentinel as well, right? So great set of
Exactly.
talks. Yeah, I think just to close it off, few line items or few action items I would want to point out. Please remember that if you didn't manage to catch the entire event, all of these talks will be uploaded to YouTube, so you will be able to see all of these sessions on YouTube later on. Apart from that, we also have HashiTalks 2026 that is coming up. It is going to be the eighth annual 24 hours event. It is again a virtual event. For if you want to basically speak at this event, then there is a link to basically apply for speaking. It is called hashi.co/hashitalks 2026. Do register for the event, and if you want to speak, do also apply for speaking to this event. And with that said, I think I would like to thank everyone for joining this event. It was a great time that we have spent together learning about the different HashiCorp tools. And
Exactly.
thank you so much to everyone who's joined in, to all the speakers for taking time and contributing to this great event. And also thanks to my co-host, Saravanan and Neil. Thank you guys for joining in, and it was great chatting with you both, and also to Jasmine and HashiCorp team. Thank you for giving us the opportunity.
Yes. So that concludes our HashiTalks India for 2025. And thank you, Aditya, Neil, and Jasmine, the entire
Yeah.
HashiCorp community for the well organized event for today.
Thank you everyone for joining.
Thank you.